Welcome to Dreams of Gravity. If you're here with us tonight, take a moment to settle in. Lie down if you can, or find a comfortable position wherever you are. Let your body sink into the softness beneath you. Release any tension from your shoulders and allow your breath to slow, like a gentle wave easing into the shore. Close your eyes if it feels right, and let the words carry you into a peaceful drift. We're here to explore the vast wonders of the cosmos together in a way that soothes the mind and invites rest. Breathe in and out. Now, let's begin our journey. Imagine the universe as an endless ocean, vast and whispering, where stars drift like bioluminescent creatures in the deep. In this ocean, there are islands of light, galaxies, swirling collections of billions of stars, held together by an invisible embrace we call gravity. Gravity, that quiet force, pulls everything toward harmony, much like the steady rhythm of your own breathing now, drawing you deeper into relaxation. Our own galaxy, the Milky Way, is one such spiral, a grand pinwheel stretching across 100,000 light years. Light years, you see, are the gentle measures of cosmic distance, the distance light travels in a year, reminding us how time and space entwine like threads in a dream. But the Milky Way is just one among countless others, each with its own rhythm and story. Take Andromeda, our nearest galactic neighbor, a majestic spiral much like ours, slowly drifting toward us at about 110 kilometers per second. In a few billion years, they might merge in a cosmic embrace, not with clash, but with a graceful swirl, forming a new entity that dances in the void. Galaxies form clusters too, bound by gravity's patient hand, creating superclusters that span hundreds of millions of light years, like vast archipelagos in the cosmic sea, where the space between is not empty, but filled with the subtle pull of unseen influences. These superclusters weave into even larger structures, the cosmic web, filaments of matter threading through voids that are larger than galaxy clusters themselves, a delicate lattice that emerged from the universe's infancy, when tiny density variations grew under gravity's nudge, much like ripples on a pond expanding into waves that shape the shore. In this web, our local group, a modest gathering of about 50 galaxies, including the Milky Way and Andromeda, huddles together, orbiting a common center of mass, a quiet family adrift in the larger flow. Beyond the local group lies the Virgo cluster, a bustling hub of over 1,000 galaxies, where interactions spark starbursts and tidal tails stretch like delicate scarves, reshaping members over eons in a slow ballet of attraction and repulsion. The cosmic web's voids, those immense empty expanses, aren't barren but laced with faint gas and occasional rogue galaxies, serving as counterpoints to the density, allowing the universe to breathe and expand without constraint. A reminder that emptiness holds as much potential as fullness in the grand design. The Laniakea supercluster, our home in this web, encompasses over 100,000 galaxies, its gravitational center drawing us along in a subtle flow toward the great attractor, a massive concentration hidden behind the Milky Way's dust, guiding the motion of clusters like an unseen current beneath the surface, where velocities reach hundreds of kilometers per second, blending local dynamics into the larger cosmic tide. Dwarf galaxies, like the Magellanic Clouds orbiting our own, add intimate scale to this hierarchy, their irregular shapes sculpted by tidal forces from the Milky Way, gas bridges connecting them in streams that fuel star formation, a symbiotic exchange where the small nourish the large, much like tributaries feeding a mighty river. Their globular clusters, ancient sentinels preserving the earliest light elements in a halo that extends far beyond visible arms. Ultra-diffuse galaxies, faint and extended, populate the outskirts of clusters, their low surface brightness hiding sparse stars in vast halos. Possibly tidal dwarfs stripped from parents or pristine relics of early formation, drifting like ethereal veils that soften the web's edges, where dark matter dominates to maintain cohesion despite the thin stellar veil. A subtle presence that underscores the hidden scaffolding's reach into the thinnest threads. Intra-cluster light, the diffuse glow from orphaned stars ejected during mergers, permeates clusters like Virgo, a faint halo unbound to any galaxy, yet tracing the gravitational potential, observed in deep imaging as a soft luminescence that connects the bright cores to the surrounding void. A luminous residue of collisions that lingers like echoes in a vast chamber, binding the ensemble in shared heritage. Barred spiral galaxies, like our own with its central bar channeling gas inward, drive secular evolution by funneling material to the nucleus, fostering ring structures and nuclear star clusters, a structural motif that reshapes arms over billions of years, turning the spiral's elegance into a dynamic core where black holes feast quietly, much like a river's bend, redirecting flow to deepen the pool below, sustaining the galaxy's inner vitality through gentle redirection. Lenticular galaxies, transitional forms with disk and bulge but little gas, evolve through environmental stripping in clusters, their smooth appearances belying past mergers that settled into quiescence, observed in color gradients that reveal dust lanes from recent accretion, a poised stillness where the galaxy pauses, like a dancer holding a graceful pose amid the cosmic waltz, conserving energy for future subtle movements in the web's embrace. Ring galaxies, rare beauties formed by head-on collisions where a smaller galaxy passes through a larger compressing gas into a ripple that births a luminous annulus, showcase dynamical artistry, their central bulges offset like quiet hearts, encircled by vibrant petals, a transient sculpture captured in Hubble images, where star formation pulses along the rim, echoing the universe's capacity for renewal even in moments of intrusion, transforming potential disruption into a delicate, glowing frame. Shell galaxies, remnants of minor mergers where stellar streams wrap around the host in concentric arcs, add layered complexity, their faint shells traced in deep surveys as fossil records of accretion, a quiet layering like sedimentary pages in a cosmic book, where each intrusion adds a chapter of gentle integration, preserving the history of encounters in visible whispers against the disk's calm surface. Polar ring galaxies, with their orthogonal gas rings accreted from disrupted companions, encircle the host like equatorial halos tilted at 90 degrees, their material orbiting in planes perpendicular to the stellar disk, observed in kinematic maps showing decoupled rotation, a rare orthogonal embrace where infalling clouds settle into stable loops, much like a necklace draped across a serene statue, adding dimension to the galaxy's quiet form without disturbing its core. Merging galaxy pairs, like the antennae, exhibit long tidal tails that stretch hundreds of kiloparsecs, gas-rich bridges fueling star clusters along their length. A dynamic encounter captured in ultraviolet, where young stars bead the streams like dewdrops on a spider's thread, illustrating how collisions, far from chaos, catalyze creation in a measured unraveling, the progenitor's disks warping into future ellipticals over hundreds of millions of years, a transformative dialogue in the cluster's gentle midst. Galaxy harassment, repeated close passages in dense environments that truncate disks without full merger, strips outer gas to quench peripheral star formation, observed in dwarf irregulars with truncated profiles, a subtle bullying that reshapes the small into passive forms, like wind pruning a hedge to a compact shape, fostering resilience in the web's crowded junctions where survival demands adaptation to the surrounding flow. Within these galaxies, stars are born from clouds of gas and dust, vast nurseries floating in the void. Picture a nebula, like the Orion Nebula, a glowing cradle where new stars flicker to life. These clouds, illuminated by the warmth of forming suns, span light years and shimmer in hues of pink and blue, as if the universe is painting its own sunset. The process begins quietly, with gravity gathering wisps of hydrogen and helium, the simplest building blocks, into denser regions. Over millions of years, these clumps collapse, spinning faster as they shrink, much like a figure skater drawing in their arms. At the center, pressure and heat ignite fusion, and a star is born, a spark in the darkness that will shine for eons. Not all births are solitary. Sometimes multiple stars emerge from the same cloud, forming binary pairs that orbit each other in eternal companionship, their lights mingling like two breaths synchronized in sleep. Our Sun, a modest, middle-aged star, has been shining for about 4.5 billion years, cradling our solar system in its steady glow. It pulls planets into orbit, like a parent guiding children in a slow, eternal dance. Yet the Sun, too, has its quiet phases, solar winds streaming out like sighs, carrying particles that sometimes dance as auroras on distant worlds, painting the skies with ethereal veils. These winds sculpt the heliopause, the boundary where solar influence fades into interstellar space, a protective bubble that modulates the flow of cosmic rays, those high-energy travelers from afar, allowing just enough to reach us and influence the subtle chemistry of our atmosphere, perhaps even seeding clouds that soften the daylight. Star formation isn't uniform across a galaxy. In the Milky Way's spiral arms, density waves, ripples in the gravitational field, compress gas clouds, triggering bursts of creation, while the central bulge hums with older, denser populations, a contrast like the bustling heart of a city versus its serene outskirts. Open clusters, loose associations of young stars like the jewel box in Crux, share a common origin, their members gradually dispersing into the field as gravity's grip loosens, leaving behind a scattering of siblings that wander independently, much like thoughts drifting after a shared conversation fades. In star-forming regions, jets of material erupt from protostellar disks, carving bipolar outflows that illuminate the surrounding gas, a dynamic punctuation in the otherwise serene collapse, signaling the vigorous youth of these emerging lights. Magnetic fields thread through these nurseries, channeling the collapse and aligning dust grains, observed in polarized light that reveals the calm order beneath the chaos, much like the subtle currents guiding a leaf's fall in autumn. High-mass stars, forming in the densest cores, ionize their surroundings to create H2 regions, bubbles of hot plasma that expand and trigger further collapses at their edges, a chain reaction of birth that propagates through the molecular cloud, fostering generations in a single expanse, where the ultraviolet glow etches intricate filigrees into the gas, a luminous embroidery of creation's first strokes. Feedback from these young stars, in the form of radiation and winds, clears the natal cloud, dispersing remnants into the interstellar medium, a dispersal that limits further formation in the region, balancing abundance with restraint, much like a garden where seedlings crowd until the sun's warmth thins their ranks, allowing survivors to thrive in open space. In infrared views from telescopes like Herschel, these processes unfold in exquisite detail, mapping the temperature gradients where cool envelopes warm to reveal embedded protostars. A thermal portrait of gestation that connects the microscopic grains to the macroscopic fires lighting the galaxy's arms. Triggered star formation, where expanding shells from prior generations compress adjacent clouds, creates sequential bursts. Observed in complexes like W3 in the Perseus Arm, a ripple effect that synchronizes births across parsecs, like echoes in a canyon fostering new resonances, ensuring the galaxy's stellar population evolves in waves rather than isolation, a communal unfolding in the spiral's gentle turn. Filamentary structures within clouds, elongated threads of dense gas supported against gravity by turbulence and magnetism, serve as highways for collapse, channeling material to hubs where clusters coalesce, mapped in ammonia lines that trace velocities along these spines, a skeletal framework that guides the nebula's evolution like veins in a leaf, nourishing the buds of future lights with patient flow. Embedded clusters, still shrouded in their birth clouds, harbor massive stars that illuminate the surrounding dust in mid-infrared, their young members locked in gravitational harmony before dynamical relaxation ejects the low-mass ones, a nascent community that seeds the field population, much like a village growing from a cluster of homes, gradually spilling into the surrounding landscape with enduring bonds. Massive star clusters, like those in starburst galaxies such as antennae, form in the wake of mergers where gas inflows overwhelm regulation, birthing supergiant complexes that outshine entire galaxies temporarily, their hierarchical structure, subclusters merging into a dense core, mirroring the larger web's assembly, observed in ultraviolet bursts that fade as feedback quenches the frenzy, a brief exuberance settling into a stable, luminous legacy, like a festival's glow dimming to the warm embers of community life. Globular cluster systems in ellipticals, numbering thousands in some cases, orbit in flattened distributions shaped by the galaxy's merger history. Their multiple populations, inner metal-rich and outer metal-poor, revealing sequential formation episodes, an archived genealogy where ancient balls of stars whisper of the host's accretion phases, like family heirlooms passed through generations, each layer adding depth to the galaxy's quiet narrative. Young massive clusters, such as Westerland 1 in the Milky Way, pack thousands of stars in parsec-scale volumes, their core collapse imminent under mutual gravity, observed in X-ray binaries forming from dynamical encounters, a dense cradle where interactions forge exotic pairs, much like a bustling marketplace where chance meetings spark lasting alliances, evolving the cluster into a stellar crossroads over eons. Protostellar cores within filaments, prestellar condensations on the verge of collapse, exhibit prestellar outflows that prefigure the jets, their infall motions traced in CO lines showing asymmetric accretion, a preparatory hush where the core gathers itself like a breath held before release, the surrounding envelope slowly unraveling to feed the growing ember at its heart. Disk fragmentation in massive disks around protostars leads to companion formation, gravitational instabilities birthing multiples directly from the swirling material, modelled in simulations where Toomri criteria allow clumping, observed in infrared interferometry as compact companions orbiting close, a self-organizing birth where the disk's whirlpool spins off siblings, adding multiplicity to the stellar family in a natural cascade of division. The gene's mass, the critical scale for gravitational collapse in a cloud, varies with temperature and density, setting the initial mass function's low end, where turbulent support raises the threshold in vigorous regions. A scale-dependent onset that sculpts the spectrum of stars from giants to dwarfs, like the size of raindrops determined by atmospheric chill, each falling to nourish the landscape differently in the cosmic precipitation. Radiative transfer in dense cores, where dust absorbs and re-emits stellar light in infrared, warms the interior to halt further infall, a self-limiting warmth observed in spectral energy distributions peaking at mid-IR, a thermal feedback that cradles the birth without overwhelming it, much like a mother's hand gently cupping a flame, allowing it to flicker steadily into full light. Speaking of planets, they are the wandering islands in this stellar sea. Some are rocky worlds like Earth, with oceans and atmospheres that breathe life into the cosmos. Others are gas giants, vast and swirling, like Jupiter with its bands of clouds and storms that rage for centuries. And then there are those far-off worlds, discovered by telescopes peering into the night. Exoplanets orbiting distant stars, some hugging their suns so closely they rain molten iron, others floating in eternal twilight. Each planet tells a story of formation, born from the same swirling disk of material that birthed its star, cooled by the vast emptiness around it. Consider the diversity. Hot Jupiters, massive worlds that migrated inward, their atmospheres thick with metals vaporized by stellar heat. Or super-Earths, larger than ours but still rocky, perhaps with deep oceans or volcanic landscapes that hint at hidden possibilities. In our own system, Venus spins slowly in the opposite direction, as if time itself reversed there, its thick clouds trapping heat in a runaway greenhouse, a reminder of how delicate balance sustains life. Mars, with its rusty dunes and ancient riverbeds, whispers of a wetter past, where water once flowed freely under a thinner sky. These worlds move in ellipses, not perfect circles, following Kepler's gentle laws, planets sweeping out equal areas in equal times, their paths a poetic ellipse that brings them closer and farther from their star, like the ebb and flow of tides in that cosmic ocean. Beyond our system, rogue planets drift untethered, ejected by gravitational tugs during their youth, surviving on residual heat from formation or the faint radioactivity within. Shadowy nomads that might outnumber bound worlds, reminding us that solitude is part of the cosmic journey. Moons add layers to these tales. Europa's icy shell hiding a subsurface ocean warmed by tidal flexing from Jupiter's pull, or Titan's thick atmosphere and methane lakes, a chilly echo of Earth's early chemistry, where organic haze drifts like morning mist, hinting at prebiotic stirrings. As you listen, feel your own world steady beneath you, connected to this cosmic family, its rotation a lullaby turning day to night, the moon's gentle tide pulling oceans in rhythm with your pulse. Exoplanet atmospheres, probed by transit spectroscopy, reveal water vapor on worlds like K2 18b, a sub-Neptune with potential hydrogen oceans, or carbon dioxide on TRAPPIST-1's rocky siblings, where habitability zones cluster close to their cool red dwarf sun. inviting speculation on life forms adapted to dimmer, longer days. Rings around gas giants like Saturn's iconic bands form from shattered moons or captured cometary debris, a shimmering adornment that catches light in intricate patterns, while icy worlds like Enceladus spew plumes from cryovolcanoes, feeding Saturn's E-ring and hinting at geothermal warmth beneath, a quiet vitality in the outer reaches. Lava worlds, such as 55 Cancri E, glow with molten surfaces where temperatures exceed 2000 Kelvin, oceans of rock boiling under tidal locking that keeps one face eternally scorched, a stark contrast to temperate zones where diamond rains might fall on Neptune-like giants, carbon compressed into gems by immense pressures, a subterranean splendor hidden from view. Dwarf planets like Pluto, with its heart-shaped glacier and hazy blue atmosphere, orbit in the Kuiper Belt's edge, a realm of icy planetesimals where resonant dynamics with Neptune sculpt populations, preserving the solar system's scattered disk as a museum of its formative violence, now hushed in perpetual twilight. Hycean worlds, hybrid ocean planets with hydrogen-rich atmospheres over water layers, emerge in models for systems around M-dwarfs. Their potential for warm, habitable seas beneath steamy envelopes, suggesting life in pressurized depths, where chemosynthesis draws energy from rocky cores, a veiled ecosystem akin to Earth's hydrothermal vents, fostering resilience in the face of stellar flares. Migration theories, like Grand Tack for Jupiter, propose early inward, then outward journeys that cleared inner zones for terrestrial build-up. A migratory choreography that set the stage for our system's calm arrangement, observed in exoplanet architectures where compact resonances hint at similar upheavals frozen in orbital chains. Ice giants like Uranus and Neptune, tilted by ancient collisions, showcase atmospheres of methane-tinged hydrogen and helium, their internal dynamos generating magnetic fields askew from rotation axes, a quirky inheritance that deflects solar winds unevenly, creating auroral displays offset from poles, a whimsical tilt in the outer calm that speaks to the chaotic sculpting of youth, now settled into quiet eccentricity. Exomoon candidates, inferred from transit timing variations around gas giants, promise hidden worlds with their own cycles, perhaps stabilizing climates on parent planets or hosting independent biospheres in subsurface seas. A nested hierarchy where moons mirror planetary diversity on smaller scales, inviting layered explorations of habitability in the stellar archipelago. Temperate exoplanets in the habitable zone of sun-like stars, like those around Kepler 452, exhibit potential for liquid water if atmospheres retain volatiles, their radial velocity wobbles revealing masses that suggest rocky compositions with iron cores, a familiar blueprint where plate tectonics might churn surfaces to regulate carbon cycles, fostering stable climates over geological eons, much like Earth's own quiet guardianship of balance. Mini-Neptunes, with puffy atmospheres of hydrogen and helium over rocky or icy cores, populate the transition between super-Earths and giants, their evaporation under stellar radiation sculpting diverse sizes, observed in radius valleys that hint at atmospheric retention thresholds, a subtle sorting where lighter envelopes escape to leave denser remnants, like mist lifting from a lake to reveal the stones beneath, defining the boundary between worlds of water and wind. Earth analogues, such as those in the habitable zone of TOI 700, show rocky compositions with possible silicate mantles, their transit depths suggesting oceans that could moderate temperatures, a serene mirror to our home where magnetic fields might shield nascent atmospheres from stellar erosion, preserving the delicate veil that allows liquid water to persist. Much like a quiet harbour sheltered from the open sea's tempests, nurturing the potential for gentle, unfolding complexity. Carbon planets, theorized around carbon-rich stars, might feature diamond interiors under thick atmospheres, their formation from soot-like dust in oxygen-poor disks, creating worlds of crystalline depth, where surface pressures forge gems from the core outward, a glittering interior glimpsed through hazy veils, evoking the universe's alchemy, turning simple elements into enduring treasures, hidden beneath layers that whisper of alternative biochemistries thriving in hydrocarbon seas. Water worlds, envelope-dominated planets with deep liquid layers over rocky cores, buoy up to 50 Earth masses before transitioning to Neptune's. Their steam atmospheres probed for disequilibrium chemistry like phosphine, suggesting internal dynamos or biological hints. A submerged realm where pressures forge exotic ices like superionic water, conducting like metals under the crush, much like a hidden aquifer pulsing with unseen currents, sustaining potential life in high-pressure harmony far from stellar glare. Pebble accretion models for super-Earths describe rapid growth from centimeter-sized aggregates in the disk's mid-plane, where aerodynamic drag concentrates solids, allowing cores to reach Mars mass in mere years. Observed in close-in multiples with uniform sizes, a swift assembly where turbulence stirs the pot to hasten coagulation, like snowballs gathering in an avalanche's gentle roll, building terrestrial bulwarks before gas dispersal clears the scene. Trojan asteroids, sharing orbits with planets at Lagrange points, stable in 1.1 resonances, populate swarms around Jupiter like the Greeks and Trojans, their collisional families tracing back to ancient impacts. A balanced entourage where gravity's equilibrium holds them in perpetual escort, much like faithful companions walking in step, adding a layer of shared journey to the planet's solitary path. Orbital resonances in systems like TRAPPIST-1, with planets locked in 8.5 or 5.3 chains, migrate inward together to avoid crossing. Their mean motion harmonies stabilizing the compact chain, observed in transit timing variations that confirm the gravitational tugs, a rhythmic alignment like dancers in a circle holding positions through mutual pull, preventing chaos in the close-knit family. Tidal evolution in close binaries reshapes exoplanet orbits over time, circularizing eccentric paths and synchronizing spins, as seen in hot Jupiters with aligned obliquities, a gradual settling where friction dissipates energy into heat, much like a river smoothing its banks over seasons, leading to locked configurations where day and night merge in eternal balance. Mantle convection on rocky exoplanets drives volcanism and outgassing, replenishing atmospheres against stellar winds, modeled for magma oceans on young worlds where silicate melting sustains a steam envelope. A dynamic recycling observed indirectly in escape rates, like Earth's own restless interior breathing life into the air above, ensuring the surface evolves in quiet, persistent renewal. Substellar companions, massive planets or brown dwarfs in wide orbits, bridge the gap to stellar binaries, their formation via gravitational instability in extended disks yielding higher entropies than core accretion, detected in direct imaging as warm glows with methane absorption, a twilight kinship where these wanderers share the star's light without close embrace, evoking the solitude of distant relatives in the family tree. connected yet independent in the stellar neighborhood. But not everything in the universe is born to stay whole. Sometimes visitors from afar arrive, fragile travelers on the currents of space. Take, for instance, the comet known as 3I Atlas. Discovered in late 2024, it was an interstellar wanderer, not bound to our solar system, but passing through from the distant reaches beyond. Interstellar comets are rare, like whispers from other stars, carrying ices from the universe's forgotten edges. 3. Our Atlas, with its elongated path stretched across the sky, a faint smudge of light against the black canvas. Scientists watched it closely, noting its unusual trajectory, a path that hinted at origins far from our sun's warmth. As it ventured deeper into our system, its composition revealed itself. Layers of frozen water, ammonia, and methane, preserved from the cold interstellar medium where temperatures hover near absolute zero. These comets, remnants from the solar system's birth or ejected from other stars, act as time capsules, their ices locking away molecules that could have seeded life on young planets. When 3I Atlas approached the Sun, the heat began to stir its surface, sublimating ices into gas that formed a coma, a hazy envelope glowing softly in the sunlight. Dust particles, freed from the nucleus, caught the light to form the tail, streaming away in a solar wind, sometimes splitting into ion tails that point directly from the Sun, a delicate flag waving in the cosmic breeze. Interstellar visitors like this one, including Oumuamua, before it, and Borisov, offer glimpses into other stellar nurseries. Their isotopic ratios, slight differences in hydrogen or carbon, telling tales of formation environments unlike our own, perhaps from the turbulent disks around young metal-poor stars in the galaxy's halo. Short-period comets, like those from the Kuiper Belt, loop back frequently, their orbits perturbed by Neptune's distant nudge, while long-period ones hail from the Oort cloud, a spherical shell encircling the solar system at up to 100,000 AU, where trillions of icy bodies wait in suspended animation, occasionally stirred by passing stars to send envoys inward. These clouds, hypothesized from comet dynamics, extend the solar system's reach, a faint halo blending into interstellar space, preserving primordial material that speaks of the nebula from which our sun coalesced. Centaurs, hybrid objects bridging asteroids and comets, tumble in the outer solar system, their icy exteriors activating as they near the sun, releasing volatiles that hint at the scattered disk's role in delivering water to inner worlds. A migratory heritage that enriched Earth's oceans through impacts long ago, now echoing in the quiet vapor trails observed by probes like Rosetta, which landed on 67P's rugged surface to sample its dusty, primitive heart. Trans-Neptunian objects like Sedna in its eccentric orbit suggest a distant inner Oort cloud, perturbed by unseen influences, perhaps from a hypothetical Planet 9, a world whose gravity ripples through the belt, aligning distant paths in a subtle gravitational symphony, challenging our map of the solar periphery, with hints of undiscovered companions lurking in the dim. Cometary organics, including complex hydrocarbons detected in spectra, carry pre-solar signatures, their chirality, handedness of molecules, potentially preserving asymmetries from the interstellar medium, a subtle bias that might influence life's building blocks upon delivery, weaving chemistry's threads across voids. Halley's Comet, returning every 76 years, exemplifies periodic visits, its retrograde orbit tracing back to Jupiter's perturbations. a predictable guest whose outbursts vary with spin state, revealing a porous nucleus that vents asymmetrically, a living relic whose passages have inspired calendars and myths, now studied for dust grains that hold solar system volatiles from 4.6 billion years past, a bridge between ancient ice and modern skies. Interplanetary dust, shed from comets and asteroids, forms a zodiacal cloud that scatters sunlight into the faint glow we see at dawn and dusk, a pervasive haze that spacecraft navigate, its composition mirroring the building blocks of planets, a fine legacy drifting eternally in the inner system, like whispers of creation lingering in the air after a soft rain. Cometary fragmentation, beyond thermal stress, can stem from internal pressures building in porous structures, leading to explosive releases that scatter debris in fan-like patterns, observed in missions like Deep Impact on Temple 1, where the ejector plume revealed layered interiors rich in volatiles, a sudden unveiling that enriches our understanding of these icy time capsules, much like cracking open a geode to find hidden crystals within, each shard holding a facet of the whole's quiet history. Interstellar dust analogues carried by these wanderers include silicate cores coated in organics, their trajectories perturbed by radiation pressure upon release, dispersing into the local medium to join the zodiacal complex, a subtle seeding that links distant origins to our system's ongoing evolution, like seeds carried on the wind, finding new soil in unexpected places, quietly enriching the landscape over time. Cometary cryovolcanism, where internal heat from radioactive decay or impacts drives eruptions on nuclei like 67P, ejects plumes of water vapor and dust, observed by Rosetta as seasonal geysers that sculpt the surface into rugged cliffs and pits. A dormant vitality stirring in the cold heart, much like underground springs bubbling through frozen earth, hinting at geological processes on scales far from our familiar worlds, where ices behave as rocks under low gravity, carving landscapes in slow, deliberate strokes. Cometary dust tails, evolving from sodium emissions in sun-grazing paths to micron-sized grains that dominate the brightness, vary in color with composition, observed in SOHO coronagraphs as curved arcs bending under Lorentz forces, a luminous trail that paints the solar vicinity with fleeting artistry, where the grain's size distribution, power laws from impacts, mirrors asteroid belts, linking these icy envoys to the rocky foundations of the system in shared debris heritage. Nuclear spin-up from asymmetric outgassing, where jets impart torque to tumble the body, leads to rotational instability and breakup, as in the case of 73P Schwarzmann-Wachmann 3, fragmenting into multiple components, a whirling unraveling observed in Hubble sequences, where the core's increasing speed echoes a dancer spinning faster until poise gives way, releasing pieces to chart-independent courses in the orbital stream. Oort cloud comets perturbed by the galactic disk's tidal field experience, flux variations over the solar system's orbit, sending episodic showers like the Taurids, their clustered arrivals tracing the cloud's inner edge, a rhythmic delivery influenced by the Milky Way's gentle undulations, much like seasonal winds stirring leaves from a distant tree, scattering them in patterned falls across the quiet ground. Cometary ionospheres, formed by solar EUV ionizing the coma, generate currents that interact with the solar wind's magnetic field, draping tails in curved sheets, modeled in hybrid simulations that reproduce disconnection events. A charged veil where electrons and ions dance in electromagnetic harmony, illuminating the interface between solar and cometary realms in subtle glows. The reservoir of inactive long-period comets, dynamically fresh from the Oort cloud, retain pristine ices unaltered by solar heat. Their low activity upon first passage revealing original compositions, observed in dynamical models as a population with hyperbolic excesses, a pure distillation of the outer nebula's chill, like untouched snow from a high peak, melting slowly to reveal its crystalline purity, offering unfiltered glimpses into the system's primordial hush. As it journeyed inward, drawn by the sun's gravity, something remarkable and poignant unfolded. According to Avi Loeb, the astrophysicist who has long pondered the mysteries of such cosmic messengers, 3I Atlas began to break apart. Into 16 fragments, it shattered, like a fragile dream dissolving at dawn. This wasn't a violent explosion, but a gentle unraveling caused by the comet's volatile ices warming under the sun's gaze. Tidal forces tugged at it, the same gravity that binds galaxies pulling it into pieces, revealing the delicate heart of these icy wanderers. Each fragment, now a smaller comet, continued its path, scattering like leaves on a quiet stream. Loeb, with his thoughtful insights, reminds us that such events are windows into the building blocks of worlds, the water, carbon, and silicates that might one day seed new planets. Imagine those fragments now, tumbling outward again, their tails fading as they recede, perhaps to influence some distant dust cloud eons from now. Comets like this teach us about fragility in the grand scale. Just as a single breath can shift the calm of sleep, a nudge from gravity reshapes a wanderer into many, each carrying a piece of the story onward. In the broader dance, such disintegrations aren't endings, but redistributions, material vaporized into the solar wind, enriching the thin interplanetary medium, or larger chunks potentially surviving to orbit the sun as sun grazers, their paths doomed to future perihelion passes, where heat claims them fully. A slow dissolution like ice melting in spring warmth. Avi Loeb's work extends to pondering if such objects could carry signs of alien technology, though in 3I Atlas's case, the breakup was purely natural, a testament to the raw physics governing these transients, inviting us to reflect on the humility of our observations in the face of such quiet spectacles. The Kreutz sungrazers, a family of comets prone to such fates, trace back to a massive progenitor shattered centuries ago, their fragments raining into the sun like tears from a forgotten era, observed by Soho's vigilant eye as bright flares against the corona's glow. Even meteor showers like the Perseids from Comet Swift-Tuttle sprinkle Earth with fiery greetings, remnants of past disintegrations that streak the summer sky, a gentle reminder of the interconnected web spanning from cometary nuclei to our atmosphere. Active asteroids or main belt comets blur the lines further, shedding dust without ices, perhaps primordial leftovers or recent collisions, their outbursts captured in surveys like pan-stars, adding nuance to the taxonomy of solar system bodies, where the boundary between rock and ice fades like mist at dawn, revealing a continuum of frozen histories. Encke's comet, with its short orbit and secular fading, exemplifies how repeated solar passages erode nuclei, reducing activity over time, a gradual quieting that mirrors the slowing of a river carving its bed, eventually leaving dry channels in the orbital record, studied through dynamical models that trace perturbations back to Jupiter's influence. Lost comets, those whose paths evade prediction due to non-gravitational accelerations from outgassing, wander unpredictably, occasionally rediscovered as faint apparitions, their irregular jets imparting torque that tumbles the core. A chaotic spin that echoes the unpredictability of thoughts in the mind's quiet drift, preserving mysteries in the solar archive. Cometary impacts on Jupiter, like Shoemaker Levy 9's spectacular breakup and plunge in 1994, scar the atmosphere with dark plumes that linger for months, injecting water and organics into the upper layers, a transient enrichment that stirs the planet's chemistry, observed as evolving scars that fade into the banded calm, a reminder of how even giants bear marks from passing guests, weaving transient tales into enduring atmospheres. Outbursts from distant comets, like those in the Oort cloud perturbed by galactic tides, can send swarms toward the inner system over long arcs. Their collective influence subtle yet cumulative in delivering volatiles, a slow infusion that has shaped planetary inventories across the solar neighborhood, much like distant rains nourishing a parched land through unseen aquifers, sustaining the cycle of renewal in quiet persistence. Hyperbolic trajectories of interstellar objects with eccentricities greater than 1 ensure one-way passages, their velocities relative to the Sun exceeding the local standard of rest. A fleeting brush that leaves spectroscopic imprints of alien ices, like a traveler's brief footprint in soft sand, washed away yet hinting at paths from far horizons, enriching our view of the galaxy's wandering emissaries. Cometary coma chemistry, where photolysis breaks down molecules into radicals that recombine into unexpected compounds, creates transient species like CN or OH, observed in fluorescence lines that vary with solar distance, a reactive haze that evolves like a fleeting perfume in sunlight, dissipating as the core recedes, leaving only the memory of its fragrant passage through our system's gentle warmth. Fragment survival post-breakup, where larger pieces retain enough cohesion to develop coma, leads to temporary swarms observable as clustered apparitions, like the 1992 breakup of 1992W, their paths diverging slowly under differential solar radiation, a familial scattering where siblings venture apart yet share the parent's legacy, each trailing faint echoes of the original's composition in their glowing veils. Enriched ejecta from disrupted comets, carrying higher dust-to-gas ratios, contribute to zodiacal cloud enhancements during active periods, modeled as temporary boosts in particle influx. A subtle fertilization of the inner system, where the fragment's bounty disperses into the perpetual haze, like petals from a blooming flower mingling with the air, perfuming the space around with transient grace. The dynamical aftermath of interstellar disruptions, where fragments integrate into bound orbits if captured by planetary perturbations, could seed the scattered disk with exotic material, a rare incorporation observed in orbital simulations, where a hyperbolic intruder bends to elliptic under Jupiter's nudge, transforming a one-way guest into a quiet resident, weaving alien threads into the solar tapestry over eons of gentle adjustment. By the way, I wonder, where are you watching from tonight? Which city and what time of day is it for you right now? Perhaps you're in a bustling place under the stars, or somewhere quiet where the night feels infinite. Wherever you are, let that thought connect us, like a shared breath across the void before we drift onward. Now, let's turn our gaze to the stars themselves, those points of light that have guided dreamers for eons. A star's life is a slow symphony, beginning in the crush of gravity within a nebula, where hydrogen atoms fuse into helium, releasing energy that pushes back against collapse. This balance, fusion's warmth against gravity's pull, sustains the star for eons. But all things in the cosmos have their seasons. When a massive star exhausts its fuel, it swells into a red giant, engulfing nearby worlds, then collapses in a supernova, a brilliant farewell that scatters elements across space. From those remnants, new stars form, recycling the universe's matter like breaths in an endless cycle. Consider the life cycle more closely. Small stars like red dwarfs burn cool and long, perhaps trillions of years, outlasting the universe's current age, their faint glow as steady companions in the dark. Larger ones, like blue giants, live fast and bright, fusing heavier elements, carbon, oxygen, even iron in their cores, until the pressure falters and collapse begins. The supernova's shockwave compresses nearby gas, triggering new births, a chain of creation from destruction. We've witnessed echoes of this. The light from supernova 1987A in the Large Magellanic Cloud reached us after 168,000 years, its neutrinos arriving moments before the light, a subtle reminder of how particles race through space at near light speeds. Variable stars, too, pulse with their own rhythms. Cepheids expanding and contracting, their brightness tied to size, serving as cosmic yardsticks to measure distances across galaxies. Their predictable winks helping map the expanding universe. In clusters like the Pleiades, young hot stars illuminate their siblings, a sparkling gathering that will disperse over time, each following its path, much like fireflies fading into the evening hush. Globular clusters, ancient spheres orbiting galactic halos, harbor some of the oldest stars, red giants cooling after billions of years, their dense cores hinting at collapsed remnants within, a treasury of the Milky Way's youth preserved in isolation. Neutron stars, post-supernova survivors, can magnetize intensely as magnetars, their flares releasing more energy in seconds than the sun in a day. Yet, from afar, they appear as steady beacons, their extremity a quiet undercurrent in the stellar chorus. White dwarfs, the fate of sun-like stars, cool slowly over billions of years, dimming to black dwarfs in the universe's deep future, their gravitational pull sometimes drawing in companions to ignite novae. Recurrent bursts that recycle material without full destruction, a gentle flare in the night. Brown dwarfs, failed stars too small for sustained fusion, glow faintly in infrared, bridging planets and stars, their atmospheres layered with clouds of silicates or ammonia, evolving slowly as they contract, a twilight zone where the line between world and sun blurs, observed in young associations where they pair with full siblings, sharing the same natal cloud's legacy. Cataclysmic variables, like dwarf novae, erupt from accretion onto white dwarfs. The instability of piled hydrogen layers, triggering thermonuclear flashes, a rhythmic pulsing that echoes the heartbeat of binary evolution, where mass transfer sculpts the companions into ever-changing forms, an intimate dance of stellar aging. Symbiotic stars, red giants paired with white dwarfs, exchange material in slow winds, the hot companion ionizing the cool envelope to create glowing nebulae, a mutual nurturing that extends their lives, observed in systems like Mira, whose long-period variability stems from pulsations amplified by the binary tug, a harmonious interplay that lights the sky with extended glows. Stellar winds from massive stars, carrying up to a solar mass per century, shape the local medium into cavities and shells, their momentum conserving angular momentum from the core, an outward breath that clears paths for supernova ejecta, linking individual lives to the galaxy's gaseous evolution in a continuous exchange. Asymptotic giant branch stars, pulsating as they dredge up fusion products to the surface, lose mass in dense winds that form circumstellar envelopes, precursors to planetary nebulae, where the central white dwarf's rebirth illuminates the shed layers, a transformative exhale that enriches the medium with carbon and S-process elements, observed in infrared excesses that trace the dust's formation, a dusty veil marking the star's gentle decline into quietude. Pre-main sequence evolution, where protostars contract along Hayashi tracks, cooling as they brighten before settling on the zero-age main sequence, unfolds over thousands to millions of years, their T Tauri winds clearing disks and signaling the onset of planetary formation. A preparatory phase where the star finds its poise, like a dancer warming before the performance, radiating the promise of stable light ahead. Runaway stars, ejected from clusters by supernova kicks in binary companions, plow through the medium at high speeds, their bow shocks compressing gas ahead to spark new formations, observed as infrared arcs around these wanderers, a propelled legacy that scatters seeds across the galaxy, much like a stone skipped across water, creating ripples far from its origin, fostering unexpected blooms in distant fields. Hypergiants, the most luminous stars like VY Canis Majoris, expand to thousands of solar radii, shedding mass in irregular eruptions that form asymmetric nebulae. Their instability a prelude to pair instability supernova in very massive cases, where electron-positron pairs reduce pressure leading to total disruption without remnant, a complete dissolution that enriches the medium profoundly, like a grand finale scattering confetti of elements into the cosmic air, leaving no core but a widespread gift for future generations. Our coronae, borealis stars, carbon-rich giants prone to sudden dimming from dust ejections, obscure their own light in episodes that last months, a self-imposed eclipse where graphite flakes form in the expanding envelope, observed as erratic dips in light curves, a mysterious fading that reveals the star's internal carbon excess, much like a lantern shrouded in its own smoke, casting intermittent shadows in the steady night, a poignant illustration of how even luminous beings can retreat into quiet obscurity. Long-period variables like Mira, with periods around 330 days, arise from convective pulsations in the envelope, where helium opacity drives the expansion phase. Their light curves asymmetric with slow rises and sharp drops, a breathing rhythm that modulates mass loss, observed in spectroscopic binaries where the companion's gravity perturbs the cycle, adding a gravitational whisper to the star's innate pulse, like a heart influenced by a steady hand, deepening the cadence of its quiet beat. Blue stragglers in clusters, brighter and bluer than cluster turnoff, form from mergers or mass transfer in binaries, replenishing the upper main sequence, their rapid rotation from merger spin evident in line broadening, a rejuvenated youth observed in Hubble color magnitude diagrams, where these outliers defy the cluster's age, like unexpected flowers blooming late in a garden, injecting vitality into the ancient gathering. Lithium-rich giants, anomalous in their surface abundance despite dilution expected from mixing, arise from extra mixing events or planet engulfment, their spikes traced to rotational history, observed in Kepler light curves as subtle asymmetries, a sudden infusion that revives the element in old envelopes, much like a forgotten spring bubbling up in parched soil, nourishing the star's outer layers with youthful chemistry. Solar analog stars, G-type dwarfs with similar metallicity and activity, serve as twins to study our sun's evolution. Their chromospheric lines revealing magnetic cycles of 10 to 20 years, monitored in surveys like Mount Wilson, a mirrored variability where spots and flares echo the sun's quiet temperament, allowing us to glimpse potential futures in these distant siblings, like reflections in a calm pond showing paths yet to unfold. Subdwarf B stars, hot helium core remnants of low-mass red giants, burn helium stably after a helium flash, their thin hydrogen envelopes causing high surface temperatures, observed as ultraviolet bright points in the Hertzsprung gap. A brief hot phase where they evolve to white dwarfs, a luminous interlude like a candle's final brightening before it settles into embers, bridging the cool giant to the cooling remnant in serene transition. Post-AGB stars, transitioning from the tip of the branch to planetary nebulae, exhibit F-type spectra with expanding atmospheres rich in S-process elements. Their protoplanetary nebulae phases, marked by bipolar outflows from disk accretion, observed in Spitzer mid-IR excesses from dust, a sculpted farewell where the star carves its envelope into elegant forms, much like an artist etching final strokes on canvas, leaving a glowing silhouette against the void. Matter, that fundamental stuff, flows through everything. It's the protons and electrons dancing in atoms, the stuff of rocks on Earth and the plasma in stars. Yet, much of the universe is dark matter, invisible scaffolding that holds galaxies together, felt only by its gravitational tug. And dark energy, an even greater mystery, accelerates the expansion of space itself, stretching the cosmic ocean wider with every passing moment. Dark matter, comprising about 85% of all matter, doesn't interact with light, yet its presence is evident in the way galaxies rotate. Stars at the edges moving too fast without it flying apart, like an unseen hand steadying a spinning top. Scientists infer it from gravitational lensing, where light from distant quasars bends around massive clusters, creating arcs and rings in the sky, as if the universe is folding a telescope's view. Dark energy, on the other hand, is the push, discovered in the 1990s through observations of distant supernova, showing the universe's expansion speeding up rather than slowing. It's like a gentle inflation in the fabric of space, perhaps a property of vacuum energy itself, where empty space holds latent potential, quietly expanding everything apart. Time, in this expanse, bends and stretches. Near a black hole, it slows to a crawl, as if the universe pauses to reflect. On Earth, we mark time by the Earth's spin and orbit, but in the cosmos, it's the pulse of pulsars. Collapsed stars spinning hundreds of times a second, their beams sweeping like lighthouses. Or the redshift of light from receding galaxies, stretching wavelengths as space grows, turning the universe's history into a color palette of the past. Baryonic matter, the ordinary kind we know, makes up stars and planets, but it's only 5% of the total. The rest is this dark duo, a hidden architecture that shapes the visible without revealing itself, much like the roots of a tree supporting branches unseen, nourishing the leaves that catch the light. Antimatter, matter's mirror, annihilates on contact with its twin, releasing pure energy, yet traces might linger in cosmic rays or early universe relics. A fleeting symmetry that balanced the scales at creation, leaving our matter-dominated realm as a subtle imbalance, pondered in accelerators where particles collide to recreate those primordial moments. Plasma, the fourth state of matter, dominates stars and interstellar space. Ionized gas responding to magnetic fields, channeling energy in solar flares or galactic jets that span thousands of light years. A fluid medium where electricity flows freely, connecting distant phenomena in unseen circuits. Bose-Einstein condensates, achieved in labs at near absolute zero, mimic cosmic behaviors like neutron star crusts, where atoms lose individuality to behave as one, a quantum coherence that suggests the universe's extremes foster unity, from the hot plasma of quasars to the cold neutrality of dark halos, all matter in varied states weaving the cosmic fabric. Degenerate matter in white dwarfs, electrons squeezed into relativistic speeds, provides the pressure against gravity, a quantum rule that halts collapse at Chandrasekhar's limit, beyond which supernovae ignite, while in neutron stars, it's the strong force binding quarks that resists, a nuclear glue holding the core in tense equilibrium, observed in glitch timings that reveal superfluid interiors, flowing without friction, a supercooled ballet within the crush. Quark-gluon plasma, recreated in heavy ion colliders, echoes the early universe's state, where quarks roamed freely before confinement into hadrons, a hot soup where color charge balanced like electric in plasma, cooling to form the protons that build atoms, a phase transition that set the stage for structure, much like steam condensing into droplets that gather into clouds, birthing the visible from the formless heat. Exotic states like strange quark matter, hypothesized in neutron star cores where up, down, and strange quarks mix stably, might underpin hyperons in the deep interior, a denser phase that alters equations of state, inferred from pulsar timing anomalies, a profound density where matter transcends ordinary nucleons, suggesting the universe harbors phases beyond our earthly grasp, a hidden fluidity in the heart of extremes. Color superconductivity in quark matter, where gluons mediate pairing, akin to electrons in superconductors, could suppress instabilities at ultra-high densities, enabling stable strange stars, a theoretical sheen that renders the core impervious to further crush, observed indirectly through mass-radius relations from gravitational waves. A quantum polish on the neutron star's dense jewel, where cooperation at the smallest scales fortifies against the cosmos's immense pressures. Axions, hypothetical particles proposed to solve strong CP problems, might constitute dark matter, oscillating in magnetic fields to convert to photons in experiments like ADMX, a ghostly field that permeates halos, gently influencing galaxy formation through self-interactions, like an invisible mist that subtly guides the flow of rivers without altering their course, adding a layer of quiet mystery to the dark scaffold's embrace. WIMPs, weakly interacting massive particles, another dark matter candidate, could annihilate in dense centers like the galactic bulge, producing gamma rays detectable by Fermi, their relic density from early freeze-out setting the abundance. A thermal heritage where these shadows from the Big Bang cluster, invisibly, shaping rotation curves like unseen companions walking beside the stars. Their elusive nature, a patient puzzle inviting ever deeper probes into the void's subtle weight. Sterile neutrinos, light dark matter particles mixing weakly with active ones, could explain pulsar kicks from asymmetric emission during supernova collapse, their oscillations probed in short baseline experiments, a faint coupling that allows them to stream freely through matter, populating halos with warm velocities that suppress small-scale structure, like gentle currents weaving through the dark web without stirring the surface, smoothing the cosmic texture on dwarf galaxy scales. Self-interacting dark matter models, where particles scatter elusively to redistribute energy in cores, resolve cusp-core discrepancies in dwarf galaxies, observed in velocity dispersions that flatten central profiles, a diffusive behavior that mimics baryonic feedback without light emission, much like fog settling evenly in a valley, tempering the sharp peaks of gravitational wells into rounded hollows, fostering a more harmonious assembly of stars within. Fuzzy, dark matter, ultralight bosons forming wave-like halos with de Broglie wavelengths suppressing cusps, oscillates coherently in galactic centers, probed by dwarf satellite distributions, a quantum haze where interference patterns carve solitonic cores, like ripples on a still pond holding form against the wind, providing a wave-like alternative to particle streams in the invisible scaffold. Modified gravity theories, altering Newtonian dynamics at low accelerations, mimic dark matter effects in galaxy rotations without new particles, tested in wide binary stars where orbital anomalies hint at deviations. A refined pull that extends the inverse square law's reach, much like a softened echo lingering longer in a vast hall, explaining flat curves without unseen mass, inviting a re-evaluation of gravity's gentle hand in the cosmic balance. Dark photons, hidden sector mediators mixing kinetically with ordinary ones, could explain muon G2 discrepancies while contributing to dark matter relic density. Their decays sought in beam dump experiments, a shadowed light that permeates the vacuum, subtly influencing particle interactions, like a veiled lantern casting faint glows through mist, bridging the visible and invisible in quiet resonance. Mirror matter, a parallel sector symmetric to ours but interacting only gravitationally, might form shadow galaxies overlapping ours undetected, their stars fusing identically yet isolated, a doppelganger universe coexisting in the same space, observed perhaps in lensing excesses, like a reflection walking beside you unseen, sharing the path yet touching only through gravity's shared embrace. Chameleon fields, scalar dark energy candidates that screen in dense environments to evade solar system tests, vary coupling strengths with local density, probed in fifth force searches on neutron stars, a shape-shifting essence that adapts to its surroundings, much like a chameleon blending with leaves, revealing its influence only in the sparse voids where it stretches freely, modulating expansion with environmental grace. Quintessence, dynamical dark energy rolling down a potential, evolves with time to alter the equation of state, tracked in supernova distances and BAO scales. A flowing field that whispers change across epochs, like a river adjusting its course over time, gently accelerating the cosmic drift without the constancy of a vacuum constant, inviting a living push to the universe's unfolding. Ah, black holes, those enigmatic depths where gravity reigns supreme. Born from the cores of collapsed stars, they are regions where matter packs so densely that not even light escapes. Imagine them as the still pools in our cosmic ocean, drawing in wanderers with inexorable calm. The event horizon marks the point of no return, a boundary softer than it sounds, where time dilates and the outside world races by. At the center lies the singularity, a point of infinite density, challenging our understanding of reality. Yet black holes aren't destroyers alone. They shape galaxies, feeding on gas to birth quasars that outshine entire star cities. Supermassive ones lurk at galactic hearts, like the one in the Milky Way, Sagittarius A, a quiet giant influencing orbits from afar. Observations from the Event Horizon Telescope have imaged these beasts, revealing glowing rings of hot gas spiraling in, the shadow of the hole itself, a dark pupil in the center. Smaller black holes, stellar mass ones, form from single stars' deaths, pairing sometimes with companions to pull in material that heats and flares as X-rays, like a cosmic heartbeat. Even primordial black holes, theorized from the early universe's chaos, might dot the void, tiny and evaporating slowly via Hawking radiation, a quantum whisper where particles pop in and out of existence near the horizon, one escaping while the other falls in, causing the black hole to lose mass over unimaginable times. Intermediate black holes, rarer still, bridge the gap, perhaps forming from star cluster collisions, their growth a stepping stone to the supermassive variety, influencing the evolution of globular clusters where ancient stars huddle. Black holes also merge, sending gravitational waves rippling outward, detected as chirps in observatories on Earth. Each event a union that births a larger entity, conserving angular momentum in a spiraling dance that echoes across the cosmos like a distant sigh. Accretion disks around them heat to millions of degrees, emitting across the spectrum from radio to gamma rays, powering active galactic nuclei that ionize gas far beyond their host, sculpting the intergalactic medium with outflows that regulate star formation on cosmic scales. In binary systems, black holes can strip gas from neutron star partners, leading to dramatic inspiral and merger, a final embrace detected in multi-messenger astronomy, where waves and light arrive nearly together, painting a fuller picture of these profound unions. Ergospheres around spinning black holes drag space-time into rotation, enabling energy extraction via the Penrose process, where particles split and one gains velocity from the frame dragging, a theoretical tap on the black hole's immense reservoir, hinting at how these entities might power the universe's most luminous objects without consuming themselves entirely. Wormholes, speculative tunnels through space-time stabilized by exotic matter, could link distant regions or even universes, a shortcut in the fabric that remains elusive, yet inspires thoughts on connectivity, where gravity's curves might fold the infinite into accessible paths, much like a dream compressing journeys into moments. Relativistic jets from accreting black holes, collimated by magnetic fields, punch through host galaxies at near-light speeds, carrying particles that produce synchrotron radiation, observed as bright lobes in radio maps, a directed exhale that seeds distant clusters with energy, influencing the large-scale structure over billions of years, a legacy of focused fury in the calm expanse. Dormant black holes, starved of fuel in quiescent galaxies, lie silent at centers, their influence subtle in orbital perturbations of surrounding stars, detected through astrometric wobbles or micro-lensing events, a hushed presence that awaits reawakening, much like embers in ash ready for a breeze, shaping the galaxy's future quiescence with patient potential. Tidal disruption events, where stars wander too close and are torn apart, flare brightly as the debris accretes, observed as transient X-ray sources with characteristic light curves, a rare unveiling of the hole's appetite, where the star's remnants circle back in stretched streams, a poignant dissolution that lights the quiet core for months, echoing the fragility of orbits in the gravitational embrace. Quasi-periodic oscillations in accretion flows, detected as X-ray flickers from the disk's inner edges, probe the black hole's spin and mass, revealing frame-dragging effects that twist the plasma into resonant modes. A subtle vibration like the hum of a tuning fork near the horizon, where the hole's rotation imprints its signature on the infalling matter, a rhythmic whisper of the singularity's hidden dance. Supermassive black hole binaries, remnants of galaxy mergers, in spirals slowly under gravitational radiation, their waves detectable in pulsar timing arrays like nanograv's recent signals, a low-frequency hum from cosmic unions that reshapes host structures like two ancient trees entwining roots over centuries, their slow merge stabilizing the forest around them in shared growth, a harmonious convergence that echoes through the universe's quiet undercurrents. Microquasars, stellar analogues to quasars in X-ray binaries, launch jets from accretion onto black holes, their radio emissions tracing relativistic outflows that mimic galactic-scale phenomena on compact scales, observed in systems like GRS 1915 Plums 105, with its heartbeats of variability, a miniature engine demonstrating the universality of accretion physics, where small systems whisper the secrets of their larger kin, bridging the intimate to the immense in a shared language of light and motion. Kerr black holes, rotating with angular momentum from progenitor spin, exhibit frame dragging that twists in falling geodesics, their ergospheres enabling superradiance where waves amplify off the rotation, a theoretical boost observed indirectly in quasar spectra, a spinning serenity where the hole's momentum imprints helical paths on the surrounding space, like a whirlpool drawing leaves into spiraling descent, enhancing the efficiency of energy release in quiet, persistent turns. Hairy black holes, exotic objects with quantum hair from Hawking radiation back reaction, deviate from no-hair theorem predictions, potentially detectable in ring-down waveforms post-merger, a subtle fuzz where information clings to the horizon, challenging the smooth baldness, much like a velvet texture on a polished stone, adding nuance to the event's edge without altering its pull, preserving echoes of the past in the gravitational chorus. Black hole shadows in clustered environments, lensed by foreground mass, create multiple images or Einstein rings around the silhouette, modeled for Virgo cluster transits, a multiplied darkness where the hole's outline duplicates across the sky, like reflections in a hall of mirrors, deepening the mystery of its presence amid the stellar throng. Photon spheres, unstable orbits at 1.5 times the Schwarzschild radius, ring with light trapped in circular paths, contributing to the bright halo in EHT images, a luminous girdle where rays orbit eternally until perturbed, observed as the photon rings faint echo, a delicate balance like birds wheeling in thermal updrafts, illuminating the boundary between capture and escape in graceful repetition. Supermassive black hole feedback in quasar mode, driving molecular outflows at 1,000 km/s that quench host star formation, regulates galaxy growth across cosmic time, traced in CO lines from ALMA, a moderating breath where the hole exhales gas to cool the frenzy, much like a thermostat easing a room's warmth, fostering equilibrium between the central engine and the surrounding stellar nursery. Isolated black holes, roaming the halo after dynamical ejections, accrete from the interstellar medium at low rates, their Hawking evaporation dominating for stellar masses, a solitary fade where isolation amplifies the quantum whisper, potentially detectable in microlensing of background stars, like a shadow passing unseen across the light, a quiet testament to the universe's scattered remnants wandering in patient obscurity. Black hole information. Paradox resolutions, via holography or firewalls, suggest the horizon encodes incoming data on its surface, recovered in radiation correlations, a preserved memory where loss is illusory, much like a book burning, yet its words etched in ash patterns, allowing the story to emerge anew from the remnants, reconciling quantum fidelity with gravitational finality in subtle harmony. Nebulae, those ethereal clouds, bridge birth and death. The Crab Nebula, remnant of a supernova seen by ancient astronomers in 1054, pulses with the energy of a neutron star at its core. A collapsed star so dense, a teaspoon weighs as much as a mountain. These remnants glow in X-rays and radio waves, invisible to the eye but alive with the universe's hidden symphony. Tying it all is the fabric of space-time, warped by mass, rippling with gravitational waves from merging black holes, echoes that travel billions of light-years to whisper of cataclysmic unions. Gravitational waves, first detected in 2015 by LIGO, are the universe's subtlest music, stretches and squeezes of space itself, passing through us unnoticed, like a breeze through an open window. They carry stories from neutron star mergers too, where gold and other heavy elements forge in the kilonova's fire, scattering jewels across the cosmos. Planetary nebulae, shed by dying low-mass stars, form beautiful shells of gas, ionized by the fading core's ultraviolet light, expanding at walking speeds into the interstellar medium. Their colors a farewell glow before they disperse. Emission nebulae, like the Eagle Nebula's pillars of creation, stand as towering sculptures of gas eroded by stellar winds. Regions where protostars emerge from the tips, a slow unveiling like dawn breaking over misty peaks. Reflection. Nebulae scatter blue light from nearby stars, creating soft halos that mimic the hush of twilight, while dark nebulae, like the horsehead, silhouette against brighter backdrops, absorbing light to reveal the universe's shadowed artistry. Protoplanetary disks around young stars, observed edge-on or face-on by ALMA, swirl with dust gaps carved by forming planets. A nursery phase where pebbles coalesce into worlds, the infrared glow betraying the warmth of accretion as material rains onto growing cores. Supernova remnants evolve over millennia, from bright shells to fading filaments, enriching the medium with heavy elements that dust up and seed subsequent generations, a legacy carried on winds that span parsecs, linking one cycle to the next in quiet continuity. Wolf Rayet stars, precursors to many supernovae, shed their outer layers in strong winds, exposing hot cores that sculpt bubbles and rings in surrounding nebulae, their spectra rich in helium and carbon, a stripped elegance that foreshadows the explosive end, where the wind's momentum shapes the remnant's asymmetry, turning symmetric blasts into sculptural echoes of the star's final breaths. The Boomerang Nebula, one of the coldest known places, expands so rapidly that adiabatic cooling drops its temperature below the cosmic background. A fleeting chill in the warm cradle of creation, reminding us that expansion can foster both growth and isolation in the cosmic nursery. Supernova imposters, like luminous blue variables, mimic explosions without destruction, shedding shells in eruptions that create pseudo-remnants, observed in Eta Carinae as a bipolar nebula from its great outburst. A dramatic flare that reveals instabilities in massive star envelopes, a prelude to true cataclysm without the finality, enriching the local bubble with metals in episodic gifts. Molecular hydrogen in photodissociation regions, where ultraviolet light from nearby stars breaks down molecules at cloud edges, reforms in shadowed zones, a resilient chemistry that traces the interface between destruction and renewal, mapped in far-infrared lines that whisper of the gas's quiet resilience. Proplids, protoplanetary disks photoevaporated by nearby massive stars, shrink under ionizing radiation, their tails streaming away like comet dust, observed in Orion as compact silhouettes against the glow, a pressured sculpting that accelerates planet formation in hostile neighborhoods, turning threat into haste in the nursery's crowded heart. Supernova remnants like Cassiopeia A, a young shell rich in ejector knots, expand into the medium, their forward shock heating gas to X-ray temperatures, while the reverse shock accelerates electrons to synchrotron glow, a dual-front evolution that etches chemical maps of the progenitor's layers, observed in Chandra images as intricate filaments that slowly diffuse, a fading tapestry where violence yields to serene integration with the interstellar flow. Herbig-Haro objects, bright knots where opposing jets from young stars collide with ambient gas, illuminate the outflows in optical lines, a luminous collision that marks the protostar's energetic debut, evolving as the jets precess or wobble from disk instabilities, tracing the hidden dynamics of formation like footprints in fresh snow, guiding us to the quiet heart where new suns settle into their glow. Supernova light echoes, where past light scatters off surrounding dust to reach us. Delayed, create expanding rings around events like V838 Monochrotis, an illusory expansion that reveals the remnant's geometry, like a lantern's beam reflecting off fog to paint shifting patterns, illuminating the nebula's structure in temporal layers. A delayed whisper from the explosion's hush. Bipolar planetary nebulae, sculpted by binary companions or magnetic fields, exhibit asymmetric lobes with waists pinched like hourglasses, their expansion velocities varying by axis, observed in Hubble spectroscopy as chemical gradients from dredged-up elements. A final artistic flourish where the star's deathbed casts elongated shadows, much like a candle's flame bending in a draught to etch its farewell in swirling smoke. Young stellar object envelopes, thick cocoons of infalling material around protostars, heat internally to drive outflows that clear polar cavities, allowing infrared escape while the equator remains shrouded. A preferential unveiling where the newborn's first light pierces the veil along cleared paths, like dawn filtering through a forest canopy to touch the forest floor in dappled patterns, marking the transition from hidden gestation to emergent radiance. Dark cloud complexes, like Taurus Auriga, host distributed star formation with low-mass stars emerging along filaments, their embedded sources revealed in sub-millimeter maps, a sparse birthing where gravity acts gently on diffuse gas, much like dew collecting on spiderwebs to form quiet jewels, fostering solitary lights in the nebula's vast hush. Eta Carinae's homunculus nebula, a bipolar shell from its 19th century outburst, expands at 600 kilometers with nitrogen-rich lobes, observed in adaptive optics as intricate knots from instabilities. A sculpted relic where the star's erratic pulse imprinted its chaos on the envelope, like a sculptor's hurried chisel leaving textured marks on marble. A dynamic portrait of near supernova turmoil, now drifting serenely outward. The Helix Nebula's cometary knots, dense globules in the planetary shell's edge, erode under ionizing radiation to form tails, their ammonia cores resisting longer, observed in HST images as finger-like protrusions, a slow dissolution where the nebula's rim frays into organic shapes, much like frost patterns melting on a window, revealing the underlying clarity in gradual poetic retreat. Infrared dark clouds, cold dense regions opaque even at 8 microns, harbour high-mass prestellar cores, their column densities exceeding 10 Mach 23 km 2, mapped by Herschel as potential sites for future clusters. A veiled sanctuary where chill preserves the gas against disruption, like a cocoon spun in shadow, nurturing the promise of vigorous births within its quiet depths. The veil, nebula, a large supernova remnant fragmenting into arcs and filaments, glows in oxygen lines from collisionally excited gas, its irregular structure from the blast's interaction with clouds, observed in narrowband filters as a shattered veil. O expansive ruin where the explosion's force wove ragged edges, much like torn silk fluttering in a breeze, softly outlining the void it once concealed. As we ponder infinity, consider the universe's scale. It's not just vast, it's boundless in ways that mirror our dreams. The observable universe spans 93 billion light-years, filled with perhaps 2 trillion galaxies, each a universe unto itself. Beyond? We don't know. Perhaps more, folding into multiverses, or curving back on itself like a dream without end. Time here is relative, measured in cosmic epochs. The Big Bang's fiery birth, 13.8 billion years ago, expanding from a hot, dense state into the cooled expanse we see. Inflation, that rapid stretch in the first instance, smoothed the wrinkles, setting the stage for stars and life. The cosmic microwave background, a faint echo of that heat, blankets the sky at 2.7 Kelvin, uniform yet rippled with tiny fluctuations that seeded galaxy formation, like the first breaths stirring a still pond. In this expanse, voids between filaments of galaxies stretch empty, yet even there, quantum fluctuations hum, potential waiting to unfold. Matter cycles endlessly. Hydrogen from the Big Bang fuses into helium in stars. Heavier elements explode outward, condensing into dust that forms new clouds, new stars, new worlds. A grand recycling where nothing is truly lost, only transformed, much like the calm exhale before sleep renews the body. The reionization era, when the first stars ignited and cleared the fog of neutral hydrogen, lit up the universe around 400 million years after the Big Bang, their ultraviolet light splitting atoms and paving the way for the transparency we observe today. Galaxy evolution unfolds in phases, early elliptical giants forming from mergers, spirals like ours maintaining arms through ongoing star formation, and irregulars sculpted by interactions, each type a chapter in the story of cosmic maturation. The epoch of galaxy assembly saw quasars blazing in the young universe, their black hole engines outshining hosts, feedback loops quenching starbirth to stabilize growth, a self-regulating harmony that allowed structures to mature without excess. In the present, lenticular galaxies bridge spirals and ellipticals, their disks settled after mergers, gas depleted to leave a quiet glow, exemplifying the universe's tendency toward equilibrium over time, much like a conversation winding down into comfortable silence. The cosmic horizon, the farthest light can reach, recedes faster than light due to expansion, a boundary beyond which causality breaks. Yet the universe's flat geometry suggests an infinite canvas where parallel regions evolve similarly, their identicalities a statistical inevitability in endless replication, pondering which we inhabit the original or a copy, a philosophical echo in the vastness. Baryon acoustic oscillations, imprints from the early plasma's sound waves, ripple through galaxy distributions today, frozen at recombination when light decoupled, serving as standard rulers to gauge expansion history, a harmonic residue that tunes our measurements of dark energy's influence, like faint chords lingering from the universe's primordial symphony. The integrated Sachs-Wolf effect, where CMB photons gain or lose energy, crossing evolving potentials in voids or clusters, adds subtle anisotropies, a dynamic imprint of growth that refines our models of dark matter's role, observed in cross-correlations with galaxy surveys, a layered map revealing the universe's breathing evolution. In the far future, as dark energy dominates, galaxies beyond the local group will recede beyond visibility, isolating our cluster in a darkening sea. Yet within, mergers like the Milky Way-Andromeda union will stir new stars, a local renewal amid the grand fade, inviting reflection on legacy in the face of isolation. Streamers of intergalactic gas, falling into clusters along filaments, heat upon infall to form intracluster medium, a hot reservoir probed by X-ray emission, where cooling flows nourish central galaxies with fresh fuel, a circulatory system that sustains activity in the web's nodes, much like rivers sustaining valleys, balancing accretion with feedback in eternal poise. The cosmic voids, vast underdensities spanning hundreds of millions of light-years, host occasional fossil galaxies, quenched early by environmental isolation. Their red, passive stars a testament to halted evolution, observed in surveys like SDSS as dim outliers. These empty expanses act as expanders in the web, their growth accelerating with dark energy, a counterbalance to the pull of filaments that draws the structure into sharper relief, like the spaces between notes defining a melody's grace. Wall-like structures, thin sheets of galaxies bridging voids and filaments, form from pancake collapses in early density fields. Their alignment with the cosmic flow a relic of initial conditions, mapped in redshift space distortions that reveal peculiar velocities. A planar whisper in the three-dimensional web where matter sheets like pages in an open book, turning the universe's narrative through layered depths. Filament spines, the densest threads in the cosmic web, host superclusters like Shapley, where galaxy infall velocities peak at thousands of kilometers per second. A gravitational highway funneling baryons toward nodes, observed in peculiar motion maps that show the universe's bulk flow toward these attractors, like streams converging on a mountain pass, guiding the flow of cosmic rivers in harmonious descent. Void walls, the boundaries where underdense regions meet filaments, exhibit enhanced galaxy clustering, a transitional zone where dark matter gradients sharpen, fostering elongated structures that connect the sparse to the dense. A subtle interface where the web's texture shifts from ethereal thinness to robust weave, much like the edge of a forest meeting open meadow, where life adapts in quiet transition. Cosmic voids expansion, outpacing the mean universe due to weaker gravity, stretches their interiors, occasionally swallowing dwarf galaxies in their slow creep, a gentle erosion observed in void galaxy proper motions, where isolation amplifies dark energy's sway, turning emptiness into a dynamic realm of subtle growth, like a quiet valley widening under persistent rains, carving space for the unseen to unfold in serene isolation. The cosmic web's nodes, where filaments intersect in massive clusters like coma, concentrate baryons into hot intracluster gas at 10 MeV 8K, their X-ray halos tracing gravitational potentials, a nexus where flows converge to pool energy, much like a town square where paths meet to share stories, fostering the dense heart of the structure in communal warmth. Skeleton of the cosmic web, the ridge lines of density maxima, traces the matter distribution's backbone, extracted from simulations to compare with observations. A linear framework where void's boundaries define the paths, like veins on a leaf channeling nourishment, guiding the universe's growth along preferred arteries of subtle pull. The large-scale dipole, our motion relative to the CMB rest frame at 370 km/s toward Leo, imprints a temperature gradient across the sky, a local drift within the larger expansion, observed in Planck data as the highest multipole, a gentle sway like a boat rocking on calm waters, revealing our place in the web's subtle current toward the great attractor. Cosmic variance, the statistical fluctuation in structure on largest scales, limits precision in measuring parameters, arising from finite volume sampling, an inherent patchiness where our observable bubble might differ from the mean. Like viewing a tapestry from one corner, appreciating its weave, yet pondering the full design's quiet uniformity beyond sight. The horizon problem's resolution via inflation, homogenizing causal patches, set the stage for the web's coherence, where disconnected regions share temperatures to parts per million, a unified canvas stretched from initial harmony, much like a shared dream linking disparate minds in seamless narrative, ensuring the structure's graceful emergence from primordial calm. Yet infinity invites philosophy. In this endless ocean, our lives are brief eddies, but connected to it all. Gravity binds us to Earth, to the sun, to the galaxy's spin, a gentle reminder of our place. Like sleep, the universe expands without hurry, inviting us to let go. Planets wander, stars fade, comets like 3 atlas fragment into stories, each a thread in the tapestry of existence. Consider the silence of space, profound and absolute, broken only by our imaginations. It's akin to the hush before dreams take hold, where thoughts drift untethered. Nebulae drift as cosmic breaths, exhaling the elements that form worlds. Black holes, in their quiet intensity, teach surrender, pulling us toward deeper understanding. Time flows not as a river, but as a sea, ebbing around islands of matter, where past and future blur in the relativity of light. We've glimpsed this in experiments, atomic clocks on fast-moving planes ticking slower, confirming Einstein's vision that motion warps time's passage, just as gravity near Earth slows it compared to distant space. In the cosmos, light from ancient quasars shows us the universe as it was billions of years ago, a window to youth, while future light will carry our era to eyes we may never know. The arrow of time, driven by entropy's increase, from ordered Big Bang to diffuse heat death, gives direction to our narratives. Yet in black holes, information paradoxes arise, suggesting perhaps loops or holograms where the universe encodes itself on boundaries, a philosophical puzzle that mirrors the way dreams recycle fragments of the day into new wholes. The holographic principle posits that all information within a volume is stored on its surface, a reduction of 3 dimensions to 2, challenging our intuition much like a shadow play captures a scene's essence without the full depth, inviting contemplation on reality's layered nature. In quantum gravity quests, string theory weaves particles as vibrating strings in extra dimensions, compactified and curled, a symphony where modes produce the particles we observe, harmonizing the small and large in a unified score. Loop quantum gravity, another path, quantizes space-time into discrete loops, a granular fabric at the Planck scale, where black hole singularities resolve into bounces, suggesting cyclic universes that rebound from crunch to bang, an eternal rhythm akin to breathing, where infinity folds into finite pulses of existence. These theories, though unproven, evoke the cosmos as a self-consistent narrative, where contradictions dissolve in deeper unity, much like worries fading in the embrace of night, leaving only the serene flow of what is. Emergent phenomena, like consciousness from neural firings, parallel how complexity arises from simple rules in cellular automata, suggesting the universe's laws bootstrap awareness from void, a bottom-up poetry where particles ponder their own dance, bridging physics and mind in quiet wonder. The simulation hypothesis, positing our reality as code in a higher computation, finds echoes in quantum indeterminacy, yet counters with the observer effect, where measurement shapes outcome, implying a participatory cosmos co-authored by its inhabitants, a collaborative dream shared across scales. Eastern philosophies, with concepts like Maya or the veil of illusion, resonate with holographic ideas, where perceived separation dissolves into oneness, a timeless unity that the cosmos' interconnected web mirrors, inviting a meditative gaze that sees self in starlight, a profound stillness where observer and observed entwine like light in a prism. Western Stoicism, too, finds kinship in the acceptance of cosmic impermanence, where stars' cycles and the universe's expansion echo the transience of all things, urging a tranquil alignment with the flow, much like settling into the night's quiet to embrace the inevitable dawn within rest. Existentialism in the cosmic context whispers of freedom amid the vast, where the universe's indifference allows personal meaning to bloom, like a lone flower in the desert finding purpose in its quiet resilience, encouraging us to craft narratives from the stardust within. A gentle affirmation that our stories, however brief, add unique hues to the infinite canvas. Indigenous cosmologies, viewing the sky as a living kin network, align with the web's interconnectedness, where stars and voids are ancestors whispering guidance, a relational harmony that complements scientific detachment with intimate belonging, much like roots intertwining beneath soil to share sustenance, fostering a holistic reverence for the cosmos as family, where every galaxy's turn echoes our own gentle rhythms. Sufi mysticism, with its whirling dervishes emulating planetary orbits, sees the universe as divine dance. The expansion of breath of the eternal, inviting surrender to the spin that carries us, a poetic fusion where physics meets spirit in ecstatic calm, like leaves twirling in autumn breeze, each motion a step in the grand unifying waltz. The concept of cosmic unity in Vedantic thought, where Brahman underlies all manifestations, parallels the field theory's unifying forces, a singular essence branching into diversity, much like a tree's trunk splitting into limbs, yet drawing from the same root, encouraging a contemplative merge of self with the all-encompassing flow, where the universe's vastness becomes an intimate mirror of inner peace. Taoist balance of yin and yang finds echo in the push-pull of dark energy and gravity, opposites in harmony shaping the web, a natural equilibrium that flows without force, inviting us to align with the Tao of the stars, drifting effortlessly in the current of existence, a serene acceptance that softens the edges of perception into gentle unity. In Platonic ideals, the cosmos as a realm of perfect forms, reflected imperfectly here below, resonates with the CMB's uniformity, a primal template echoed in structures, a philosophical ascent from shadows to light that mirrors our journey from daily concerns to cosmic contemplation, finding eternal truths in the night's quiet revelations. Aristotelian teleology, purpose inherent in natural motion, sees stars tending toward their spheres and galaxies to wholeness. A directed unfolding where each part serves the greater harmony, much like breaths serving the rhythm of sleep, guiding us toward restful completion in the universe's purposeful embrace. The Hermetic Principle. As above, so below, links microcosmic atoms to galactic scales, vibrations echoing across realms, a correspondence that weaves personal introspection with stellar observations, fostering a meditative synthesis where inner voids and cosmic ones blend in shared silence, a profound interconnection that lulls the mind into tranquil oneness. Buddhist emptiness, shunyata as interdependent arising, parallels the quantum vacuum's potential, where phenomena emerge from relational voids without inherent existence, a non-dual view that the cosmic web embodies, inviting compassion for the illusory self amid the stars, like mist dissolving to reveal the mountain's true form, fostering equanimity in the infinite's gentle flux. Confucian harmony, Tian Ren He Yi of heaven and human unity, sees cosmic order mirroring social balance, where the universe's laws guide ethical living, a relational cosmos where planets' orbits inspire virtuous cycles, much like a well-tuned instrument resonating with the ensemble, encouraging alignment with the natural Tao in personal and stellar scales alike. Epicurean atomism, random swerves in void-birthing worlds, anticipates modern cosmology's fluctuations. A materialist serenity where fear of the divine yields to nature's quiet mechanics, pondering atoms' eternal dance as the source of all, like leaves falling in autumn to enrich the spring soil, a cycle of chance yielding beauty without cosmic decree. Kantian's sublime, the vastness evoking awe beyond reason, captures the universe's infinity stretching the mind, a moral elevation where the starry heavens above prompt duty within, inviting reflection on our smallness as catalyst for greater purpose, much like gazing at ocean waves to feel the soul's depth, blending terror and tranquility in philosophical repose. Nietzschean eternal return, willing the cosmos's recurrence, challenges us to affirm life cycles in stellar rebirths, a Dionysian embrace of the universe's flux, where black holes pull and expansions push, echo the will to power, like a flame consuming itself to rise anew, urging joyful acceptance of the infinite's recurrent song. Jungian archetypes in the collective unconscious find cosmic projections in galaxy forms, spirals as mandalas of wholeness, a psyche mirroring the macrocosm, where dreams of stars tap ancestral skies, fostering individuation through stellar symbolism, much like navigating by constellations to find inner north, uniting personal myth with the universe's archetypal hush. Phenomenological bracketing, suspending judgments to experience the cosmos raw, reveals space-time's lived texture, a Husserlian return to things themselves, where black holes' mystery invites pure wonder, like closing eyes to hear the night's true silence, peeling layers of assumption to touch the essence of infinity in meditative immediacy. Heideggerian being towards death, echoed in stellar evolutions, calls authentic dwelling amid transience. The universe's heat death, a distant horizon sharpening presence, much like a candle's flame aware of its end, illuminating the now with quiet intensity, encouraging resolute care in the cosmic thrownness. Feminist cosmologies, reimagining the universe as nurturing matrix rather than mechanical clock, highlight dark energy's creative expansion as womb-like, weaving Gaia principles into galactic webs, a relational cosmos where voids birth filaments like cycles of loss and renewal, inviting embodied wisdom in the star's maternal embrace, like Earth's tides responding to Moon's call, harmonizing body and boundless in gentle reciprocity. Post-colonial stellar narratives, decolonizing astronomy from Eurocentric gazes, incorporate indigenous star lore with modern data, such as Aboriginal songlines mapping the Milky Way, a hybrid knowing where science meets oral traditions, fostering inclusive wonder, much like rivers carrying stories from source to sea, enriching the cosmic tale with diverse voices in shared serenity. Ecofeminist deep ecology, seeing the universe as interconnected web of life, extends planetary care to cosmic scales, where black holes recycle matter like decomposers in forests, urging ethical extension to the void, a holistic reverence that binds human fragility to stellar impermanence, like threads in a global tapestry, weaving sustainability into the infinite's quiet pattern. Transhumanist visions, uploading consciousness to probe black hole horizons, blend philosophy with future tech, pondering mind's escape from entropy via simulation, a Nietzschean overcoming where stars become canvases for eternal recurrence, much like dreams transcending flesh to wander realms, inviting evolution toward cosmic unity in thoughtful transcendence. Pragmatist instrumentalism, Dewey's view of knowledge as tool for adaptation, applies to cosmology's models refining predictions, where infinity's puzzles drive inquiry without final truths. A practical engagement like charting stars for navigation, fostering growth in the universe's unfolding mystery through experiential harmony. Structuralist linguistics in cosmic terms, Saussure's signs relating to the relational web, sees galaxy forms as signifying systems, where void's absences define filament's presence, a semiotic universe where meaning emerges from differences, much like words gaining sense in context, inviting interpretive depth to the starry lexicon in philosophical quietude. Expanding further, think of the interstellar medium, that thin soup between stars, mostly hydrogen, sparse as a whisper, yet vital for connecting the dots. Dust lanes in galaxies absorb light, reddening it, creating the infrared glow we detect with telescopes like Spitzer or James Webb, revealing hidden nurseries and the birth pangs of solar systems. Rogue planets ejected from their orbits wander alone, warmed perhaps by internal heat or the faint pull of passing stars, ghosts in the machine of creation. Asteroids and meteoroids, rocky siblings of comets, circle the sun in belts, remnants of failed planets, occasionally streaking as shooting stars, fleeting lights that remind us of the dynamic undercurrent in apparent calm. The heliosphere, our sun's bubble in the galaxy, shields us from cosmic rays, high-energy particles from supernovae that would otherwise bombard Earth. Yet some slip through, sparking innovations in auroras and even influencing cloud formation, a subtle dance between solar and cosmic forces. Cosmic rays, protons accelerated to near-light speeds in shock fronts, cascade into secondary particles in our atmosphere, producing muons that rain down harmlessly, a constant patter from the universe's energetic underbelly. In denser regions like molecular clouds, carbon monoxide and water vapor trace the paths of future stars, their emissions mapping the chill where temperatures drop to 10 Kelvin, cradles of complexity where organic molecules like glycine, the simplest amino acid, have been detected, hinting at chemistry's quiet prelude to life across the void. Polycyclic aromatic hydrocarbons, carbon skeletons common in these clouds, fluoresce under starlight, contributing to the diffuse interstellar bands, mysterious absorption lines in spectra, long sought as molecular fingerprints, now linking to the organic haze that permeates space, a universal ingredient ready for planetary alchemy. The local bubble, a cavity carved by ancient supernovae around our solar system, fills with hot, low-density plasma, its walls traced by soft X-rays, a recent scar in the interstellar medium that our Sun traverses, modulating the influx of material that shapes the heliosphere's edge, a local haven amid the galaxy's turbulent breath. Interstellar grains, micrometer-sized specks, drift through this medium, occasionally impacting spacecraft like Voyager. Their composition, silicates, carbons, ices, revealing the slow evolution of dust from stellar outflows, recycled through the cycle of destruction and rebirth, a fine powder that seeds the opacity of nebulae and the glow of zodiacal light at dusk. The warm, ionized medium, filling much of the galactic disk, conducts electrons from hot stars, creating a diffuse glow in H-alpha, a pervasive warmth that links discrete sources into a unified haze, while the hot ionized medium from supernova shocks pressures the cooler phases, driving a multi-phase equilibrium where turbulence mixes layers, a dynamic balance observed in absorption lines that probe the gas's velocity dispersion, like whispers of wind through a forest canopy. Coronal mass ejections, bursts of plasma from the Sun's corona, propagate through the heliosphere to sculpt the bow shock around the system, interacting with interstellar neutral atoms to produce pickup ions that energize the boundary. A solar sigh that ripples into the galaxy's medium, influencing local magnetic draping where fields align like fabric over the bubble's form. The galactic fountain, where supernova-heated gas rises from the disk into the halo, cools, and rains back as infalling clouds, recycles metals, and sustains the thin disk's evolution. A vertical circulation observed in high-velocity clouds that bridge the plane to corona, much like a gentle updraft carrying leaves skyward, only to settle them anew, nourishing the soil below in perpetual renewal. Magnetic reconnection in the interstellar medium, where twisted field lines snap and reform, releases energy to heat plasma or accelerate particles. A sporadic spark that punctuates the calm, inferred from Faraday rotation measures that map field strengths. A hidden current weaving through the gas, like underground rivers shaping the land above, fostering the subtle dynamics that sustain the galaxy's gaseous breath. Supernova-driven bubbles, expanding shells of hot gas that envelop multiple star-forming regions, create superbubbles tens of parsecs across, their interiors laced with cooler filaments where new clouds condense, observed in ROSAT X-ray surveys as faint halos around OB associations, an expansive cradle that nurtures the next wave of stars, like a vast atrium where light filters through to encourage growth in sheltered nooks, balancing destruction's wake with creation's promise. The cold, neutral medium, dense pockets shielded from ionization, hosts atomic hydrogen that self-shields to form molecules, a quiescent reservoir mapped by 21 simultimeter lines, where slow thermal motions preserve the gas against turbulence, a serene underlayer where future clouds gather in hushed anticipation, much like still waters pooling before a stream's gentle flow. Turbulent cascades in the interstellar medium, from large-scale driving by supernovae to small-scale dissipation, maintain the multi-phase structure, with Kolmogorov scaling in velocity spectra, observed in HI turbulence maps, a fractal energy transfer where eddies break into smaller ones, like waves on a pond subdividing in endless refinement, sustaining the medium's dynamic yet balanced state. Atomic fine structure lines, like CES2 at 158 microns, trace cooling in photoionized regions, their intensities balancing heating from stars. A radiative equilibrium observed in ferrous data, a thermal whisper where the medium exhales excess energy, much like a body cooling after exertion, restoring poise through gentle emission into the night. Molecular line ratios, such as HCN, HCO+, indicating dense gas fractions, probe star formation efficiency in clouds, where high ratios signal shielded cores, mapped in apex surveys, a chemical fingerprint of compression, like scents rising from crushed herbs, revealing the hidden pressures nurturing lights within the nebula's fold. Dust grain alignment with magnetic fields via paramagnetic dissipation polarizes background light, observed in Planck foregrounds as E-mode patterns, a magnetic imprint where grains spin like tiny tops, orienting the medium's veil, much like compass needles aligning to Earth's field, guiding the flow of light through the interstellar haze in ordered subtlety. Interstellar scintillation, twinkling of radio sources from electron density fluctuations, probes turbulence scales in the warm medium, with diffractive and refractive regimes, observed in pulsar dynamic spectra, a rippling distortion like heat haze over pavement, bending signals to reveal the medium's restless undercurrents in quiet interference. The molecular hydrogen fraction, traced by UV absorption in Lyman-Werner bands, varies with metallicity and radiation fields, self-shielding to protect against dissociation, a resilient bond forming in shadowed niches, much like friendships forged in adversity, sustaining the chemistry of clouds against the stellar glare. Ionized carbon trails from cosmic rays, producing sea pools in diffuse gas, serve as ionization tracers, their recombination lines balancing production, observed in radio recombination spectra, a charged pathway where particles carve faint paths through neutrality, like sparks trailing in dark air, illuminating the medium's response to high-energy visitors. In this meditation on the infinite, we touch on the quantum realm, where the very small mirrors the vast. Particles entangle across distances, spooky action that defies space's separation, suggesting the universe's underbelly is woven from connections unseen. Wave functions collapse upon observation, as if reality awaits our gentle gaze, much like dreams solidify from vague impressions. The Higgs field, pervasive as space itself, gives particles mass through interaction, the reason gravity can hold sway. Without it, matter would zip light speed, formless and free. These layers, from quantum foam to galactic webs, build the whole, inviting us to ponder our own place. Atoms in our bodies forged in ancient stars, stardust breathing, thinking, dreaming under the same sky. Quantum tunneling, where particles slip through barriers, might explain how stars ignite despite the energy needed, or how alpha decay happens in nuclei, a probabilistic whisper enabling change. In the early universe, quantum seeds grew into structures via inflation's amplification, turning microscopic jitters into the grand architecture we survey. Even dark energy could tie to quantum vacuum fluctuations, virtual particles lending a repulsive force on large scales, a balance where the cosmos's push and pull find equilibrium. much like the inhale and exhale that now carries you toward rest. Decoherence, the process by which quantum superpositions fade into classical outcomes through environmental interaction, explains why the macroscopic world feels solid, a transition as smooth as wakefulness yielding to sleep, where possibilities narrow to one coherent path. In cosmology, eternal inflation spawns bubble universes within a larger multiverse, each with varying constants. Our own a fortunate draw where atoms bind and stars shine, a selection effect that underscores the improbability of existence, yet comforts in its quiet affirmation of place. Bell's theorem tests confirm non-locality, where entangled photons correlate instantaneously regardless of distance, challenging classical intuitions and hinting at a holistic universe where separation is illusory, much like how memories link disparate moments in a life story. In neutron stars, quantum degeneracy pressure from paused electrons and neutrons resists further collapse, a Pauli exclusion principle at work on cosmic scales, balancing the inward crush in a sphere mere kilometers across. Their glitches, sudden spin changes, arising from crustal quakes that release stored strain, a subtle tremor in the dense heart of matter's extremes. Casimir effect, where vacuum fluctuations between plates create attractive force, demonstrates the quantum field's tangible pull, a microcosmic echo of dark energy's repulsion on vast scales, suggesting the empty space between atoms hums with potential, a latent energy that permeates all, from the void between galaxies to the spaces in our breath. Superposition in quantum bits, harnessed in computing, parallels the universe's early state where all outcomes coexisted until measurement, a computational vastness that might simulate cosmic scales, where entanglement networks mimic the web's filaments, a digital analogy that blurs the line between model and reality, inviting us to see the cosmos as an immense algorithm unfolding in serene computation. Quantum field theory, underlying particle interactions, describes forces as exchanges of virtual carriers, gluons for strong binding, photons for electromagnetic dance, a pervasive field where excitations manifest as the particles we measure, a foundational weave that unifies the microcosm, much like threads in a vast loom crafting the fabric of events from probabilistic potentials. Anyons in two-dimensional systems, particles with fractional statistics that braid rather than commute, emerge in topological quantum computing, echoing possible behaviors in the early universe's planar symmetries. An exotic twist where paths entwine without collision, suggesting the cosmos might harbor braided dimensions at its edges, a subtle interlacing that adds depth to the quantum cosmic tapestry, like vines climbing a trellis in quiet harmony. Topological defects, such as cosmic strings from phase transitions in the early universe, could thread through space as stable relics, their gravitational lensing detectable as double images of background sources, a linear whisper of inflation's turbulence, where loops oscillate and decay into gravitational waves, contributing to the stochastic background, like faint scars from the universe's youthful stretching, now lingering as gentle reminders of its formative tensions. Domain walls, hypothetical sheets separating regions of different vacuum states, might arise from symmetry breaking, their immense energy density curving space profoundly if they persist, though observations limit their abundance, a speculative barrier in the multiverse's bubbles, where such walls could isolate realms like veils in a dreamscape, preserving distinct realities in the infinite's quiet partitions, a conceptual hush where transitions mark the boundaries of possibility. Monopoles, point-like defects with magnetic charge, dilute during inflation to evade detection. Yet, if present, catalyze baryogenesis via interactions, probed in primordial spectra, a singular anomaly where north and south poles unite in one entity, like a compass frozen at true north, potentially seeding matter's asymmetry in the early plasma's swirl. Texture models, from global symmetry breaking, form unstable knots that decay into radiation. Their gravitational imprint subtle in CMB power spectra, a knotted complexity unraveling to smooth the field, much like tangled yarn pulled straight to weave a scarf, contributing to the universe's early homogenization in quiet dissolution. Quantum entanglement entropy, measuring correlations across horizons, bounds the information content in black holes via the page curve's peak and decline, a thermodynamic accounting where entanglement links interior to exterior, like invisible strings tying distant notes in a melody, preserving unity in the divide of event and outside. ADS, CFT correspondence, holography in anti-de Sitter space, maps gravity to boundary quantum theory, a duality where bulk geometry emerges from field correlations, observed in toy models of black hole evaporation, a reflective principle like a cave's shadows revealing the fire's dance, bridging curved space to flat theory in profound analogy. Quantum Darwinism, where classical reality emerges from pointer states robust to decoherence, selects stable outcomes via environmental replication applied to cosmic structure, where quantum branches yield the observed web. A survival of the fittest configuration, much like species adapting to niches, evolving the universe's face from quantum multiplicity to classical serenity. The Wheeler-DeWitt equation, timeless quantum gravity wave function, describes the universe as stationary superposition, challenging arrow of time's emergence, a eternal now where change is illusory, like a painting capturing motion in stillness, inviting contemplation on time's subjective weave within the quantum whole. Path integral formulations in quantum cosmology, summing histories to yield the wave function, incorporate wormhole contributions for topology change, a probabilistic tapestry where all geometries contribute weighted by action, much like dreams blending paths into one narrative, crafting the cosmos from infinite possibilities in weighted harmony. Black hole complementarity, resolving paradoxes by locality on different horizons, posits non-overlapping descriptions for observers, a relativistic truce where information duplicates without cloning, like two maps of the same land from opposite shores, allowing consistency in the horizon's dual gaze without contradiction. Firewalls at horizons, proposed to preserve unitarity, create high-energy barriers for infalling observers, debated in AMPS paradox resolutions, a fiery threshold where smooth geometry yields to quantum rigor, much like a veil of flame guarding a sanctuary, protecting the interior's secrets at the boundary's edge in tense equilibrium. Wandering deeper into the philosophical currents, reflect on the Fermi paradox. Where are the others in this teeming expanse? With billions of potentially habitable worlds, from Earth-like zones around red dwarfs to ocean planets in the trillions, the silence suggests filters, perhaps great or self-imposed, yet it also underscores our solitude's beauty, a private dream in a shared night. Biosignatures, like atmospheric oxygen, or technosignatures such as laser pulses, elude us so far, but missions like those probing exomoons or subsurface habitats remind us that life might thrive in cracks we overlook, resilient as thought in quiet moments. The universe's habitability curve peaks not at the beginning or end, but in its middle ages, when metals from stars enrich planets without over-ionizing atmospheres. A window where carbon-based forms could emerge, evolve, and wonder as we do now. In this vastness, entropy's march toward disorder is countered by local order, galaxies coalescing, life organizing against the gradient, mirroring how a single focused mind can weave coherence from chaos, much like this narrative threading facts into reverie. Panspermia, the idea that life hitchhikes on comets or dust, spreads across systems, suggests interconnected origins, where microbial seeds from one world find purchase on another, a cosmic dissemination as gentle as pollen on the wind. The anthropic principle, observing that the universe's laws allow observers like us, prompts reflection on fine-tuning, why gravity's strength or the strong force's binding permits complexity. Perhaps a multiverse lottery or deeper necessity, a mystery that invites humility, aligning our wonder with the cosmos's patient unfolding. As we contemplate these depths, the universe reveals itself not as a machine, but a living poem, each element a verse in an ongoing stanza, drawing us into its rhythm where questions dissolve into serene acceptance. The rare Earth hypothesis posits that complex life requires a confluence of factors: stable orbits, plate tectonics, large moons, making us less unique, yet more cherished in our niche, a delicate bloom in the cosmic garden. Setai's quiet listening, scanning radio quiet zones for deliberate signals, embodies patient hope, where the absence of noise might itself be meaningful. A vast library awaiting the right query, reminding us that discovery often lies in the spaces between transmissions, much like insight emerging in the pause between thoughts. The zoo hypothesis, envisioning advanced civilizations observing us discreetly, paints the silence as intentional reserve, a galactic ethic preserving our natural development, akin to a nature reserve where watchers tread lightly, allowing evolution's quiet unfolding without interference, a benevolent veil over the stars. The berserker hypothesis, a darker note, suggests self-replicating probes destroy emerging life to prevent competition. Yet even this evokes cautionary wisdom, urging us toward harmony in our own ascent. A narrative thread that tempers ambition with care, much like a storyteller weaving warnings into tales for the listener's gentle repose. The great filter, whether technological self-destruction or insurmountable biological hurdles, challenges us to navigate wisely, turning the paradox into a call for stewardship, where our choices ripple like stones in a still pond, shaping the silence into potential chorus, a philosophical nudge toward mindful existence amid the stars' watchful quiet. Transcension hypothesis, proposing civilizations retreat inward to higher dimensions or simulations rather than expand outward, explains the quiet by inward focus, a contemplative withdrawal that mirrors personal meditation, where exploration turns introspective, seeking depths within rather than breadths without. A serene pivot that enriches the inner cosmos as profoundly as the outer, inviting us to find our own quiet frontiers in the mind's vast interior. The eusocial hypothesis, drawing from insect colonies, suggests advanced societies evolve toward collective minds over individuals, their signals subtle and unified, perhaps detectable only in coordinated patterns across stars. A harmonious hive where consciousness merges like rivers into an ocean, explaining the quiet as a deeper, shared resonance beyond our solitary calls. much like a choir's breath aligning before the song, fostering unity in the cosmic symphony. The dark forest hypothesis, envisioning the universe as a cautious wilderness where civilizations hide to avoid predators, casts silence as survival's veil, a prudent hush that encourages peaceful coexistence through non-detection, like nocturnal creatures navigating by faint sounds, preserving the delicate balance where presence is felt but not proclaimed, a wise restraint in the infinite woods. The communication hypothesis posits that advanced signals evolve beyond radio to compressed, undetectable forms, like neutrinos or gravitational waves, their messages encoded in the universe's fabric itself, a subtle dialogue we might overlook, much like whispers carried on the wind blending with the breeze, requiring attuned ears to discern the conversation hidden in nature's own voice, turning the silence into a sophisticated layer of interaction beyond our current grasp. The planetarium hypothesis, suggesting a simulated reality tailored to our observations, renders the quiet as programmed absence, a cosmic stage where extras are omitted for narrative focus, like a play with empty seats beyond the spotlight, inviting meta-reflection on perception's role in constructing the infinite, a philosophical loop where detection shapes the detected in serene illusion. The supertask hypothesis, where advanced computation solves paradoxes instantaneously, allows civilizations to transcend time's arrow, their activities compressed beyond our linear grasp, explaining non-detection as dimensional mismatch, much like watching a film frame by frame missing the motion, a higher tempo where infinity's events unfold in eternal now, fostering humility in our temporal slice of the cosmic play. The aesthetic filter, proposing that beauty drives expansion, but rarity limits signals, sees the universe as an art gallery with sparse masterpieces, where harmonious forms like spirals inspire but don't broadcast. A selective silence valuing subtlety, like a garden pruned for elegance over abundance, encouraging us to appreciate the quiet beauty in our corner of creation. The metabolic hypothesis, linking life to stellar energy gradients, suggests habitability windows, narrow to specific epochs, with post-stellar eras too diffuse for complex metabolism. A temporal filter where our timing is fortuitous, much like catching a sunset's glow before night falls fully, pondering the universe's rhythmic pulses that align life with luminous phases in gentle synchrony. The simulation argument's nested levels, where ancestors simulate progeny, multiplies realities exponentially. The quiet, a base layer's echo or sim's efficiency. A recursive dream where each layer ponders its own silence, like stories within stories fading into the teller's hush, blurring creator and created in infinite regress. The religious hypothesis, positing divine orchestration with intentional isolation for spiritual growth, frames the paradox as purposeful solitude, a sacred quiet for soul's journey, much like a retreat in wilderness fostering inner light, weaving faith with physics in contemplative harmony, where stars serve as celestial guides without direct word. Delving into the elemental forge, consider nucleosynthesis, where stars craft the periodic table's diversity. Big Bang nucleosynthesis yielded light elements, hydrogen, helium, trace lithium. In the first minutes, their abundances etched in the oldest stars, a baseline from which stellar hearts build heavier kin. In main sequence cores, the proton-proton chain, or CNO cycle, fuses hydrogen to helium, a steady alchemy that powers the sun's calm radiance, while in massive stars, successive shells burn helium to carbon, carbon to neon, layering like an onion until iron's core stalls the process, tipping toward collapse. Rapid neutron capture, the R process in neutron star mergers or supernovae, snatches neutrons to forge gold, uranium, the rapid buildup followed by beta decays that stabilize the chain, a frantic synthesis in explosive instants that scatters these rarities to dust up in nebulae. The S process, slower in asymptotic giant branch stars, allows captures between neutron pulses, filling gaps for elements like barium, a patient weaving in the red giant's envelope, where convective mixing brings neutrons from alpha captures on iron seeds. These processes, observed in spectra of metal-poor stars that preserve early enrichments, trace the galaxy's chemical evolution from pristine gas to the metallicity that enables rocky planets and life, a progression where each generation inherits and adds to the palette, turning the universe from simple to sublime over billions of years. Isotopes like carbon-13, produced in CNO cycles, vary across stars, their ratios a fingerprint of interiors, while deuterium, fragile and destroyed in stars, survives only in the interstellar medium as a relic of the Big Bang, a faint echo measured in absorption lines, underscoring the irreplaceable gifts of the origin. Intermediate elements like silicon and sulfur from silicon burning in pre-supernova cores peak in the explosive silicon flash that unbinds the star, their yields depending on progenitor mass, modeled in simulations that match observed abundances in metal-rich stars, a calibrated forge where the universe's inventory balances through stellar demographics, ensuring the silicates in Earth's crust trace back to these fiery workshops. Cosmic ray spallation, high-energy impacts shattering nuclei in the interstellar medium, produces light isotopes like beryllium and boron, a secondary synthesis that supplements stellar output, observed in variations across galactic arms, where ray fluxes differ, a diffusive seasoning to the primary menu. Lithium-7, a Big Bang product depleted in stars by mixing to hot regions, shows plateaus in halo dwarfs, a nucleosynthetic puzzle resolved by spallation contributions, where galactic rays refine the primordial yield, a subtle adjustment that harmonizes the light end of the table, much like fine-tuning an instrument before the symphony begins. P-per process elements, like technetium in red giants, arise from proton captures in explosive or hot bottom-burning environments, rare isotopes that fill the table's odd corners, detected in spectra as fleeting presences before stellar winds disperse them, a specialized craft in the cosmic smithy that completes the palette for planetary diversity, ensuring even the scarcest threads contribute to the weave of worlds. Gamma process nucleosynthesis in supernova shocks where high-energy photons photodisintegrate seeds to build proton-rich isotopes, crafts rare nuclides like aluminum-26, whose decay heats young solar systems and powers early activity, a fleeting energy that stirs the protoplanetary disk like a warm hearth in winter, dispersing traces that linger in meteorites as signatures of the forge's final sparks, linking stellar death to the birth of habitable cradles. Neutrino nucleosynthesis in core collapse supernovae, where electron neutrinos drive neutronization, influences the weak interactions that seed our process sites, their fluxes modulating the neutron-to-proton ratio in the protoneutron star, a subtle nudge from the invisible that tips the balance toward heavy element production, like a hidden current steering the river's flow, ensuring the explosive bounty includes the seeds of future complexity in quiet, pervasive influence. The new process, neutrino spallation on seed nuclei in the supernova envelope, produces light P nuclei like deuterium or helium-3 in the hot, dense layers, a gentle irradiation where weak interactions chip away at abundance peaks, observed in isotopic ratios of pre-solar grains. A delicate etching that refines the elemental mix, much like a soft rain washing fine details into stone, adding nuance to the forge's robust output with whispers of subtlety. Triple alpha process enhancements in rotating massive stars, where angular momentum mixes carbon to the surface, boost S process sites, observed in spin rates of progenitors, a whirling acceleration that stirs the core like a gentle vortex, enriching the envelope with helium-burning products, fostering heavier forges in the star's layered heart. Explosive burning in white dwarf detonations, type Ia supernovae, synthesize iron group elements via carbon-oxygen fusion, their peak luminosities standardizing distance measures, a calibrated blast where the flame front propagates subsonically or deflagrates, modeled to match spectra of nickel-56 decay powering the light curve, like a controlled bonfire illuminating cosmic scales, linking stellar ends to the universe's measured expansion. The VP process, neutrino-driven proton capture in neutrino winds from protoneutron stars, fills light P nuclei gaps, high entropies allowing proton-rich paths, inferred from pre-solar grain isotopes, a windy forge where neutrinos seed the flow, much like a breeze carrying sparks to ignite distant tinder, crafting rarities in the supernova's outflowing breath. Stellar rotation effects on yields, faster spins in POP3, stars enhancing mixing for higher metals, alter initial mass functions, simulated in Geneva models, a dynamic twist where centrifugal forces dredge deeper, like a potter's wheel shaping clay into varied forms, diversifying the early universe's palette for subsequent generations. AGB nucleosynthesis, hot bottom burning, where convective envelopes reach ignition for CNO and NENE cycles, produces nitrogen enhancements in luminous cases, observed in TP-AGB stars spectra, a simmering surface where base temperatures forge light elements, much like a pot on low heat. Infusing flavors slowly, enriching the wind with subtle chemistries before the nebula's birth. Cosmic ray propagation through the galaxy, diffusive and leaky box models fitting boron to carbon ratios, constrain halo sizes and residence times, observed in AMS-02 data. A galactic journey where particles scatter off magnetic irregularities, like wanderers delayed by winding paths, gradually enriching the medium with spallation gifts along their meandering way. Presolar grain stardust, captured in meteorites, preserves isotopic anomalies from individual stars. Psi-C from AGBs showing silicon-28 excesses, analyzed via nanosims, a tiny archive where ancient forgers' signatures endure, like letters from distant scribes sealed in stone, revealing the diversity of nucleosynthetic voices across time. Reflecting on cosmic evolution, trace the timeline from singularity to now. The Planck epoch, first 10,000 watts, 43 seconds, defies description, where quantum gravity reigned, space-time foam bubbling in uncertainty, transitioning to grand unification where forces began to differentiate, a nascent unity splintering into the familiar quartet. Electro-weak symmetry breaking birthed the Higgs mechanism, endowing particles with mass, while inflation's exponential growth diluted relics, setting a homogeneous stage with quantum imprints as seeds. Quark-gluon plasma cooled to form protons and neutrons, then light nuclei in the brief nucleosynthesis window, before recombination freed photons into the CMB's glow. Dark ages followed, a neutral fog until the first stars, massive population 3, ignited, their fusion ionizing the medium and forging the first metals, clustering into proto-galaxies that merged hierarchically, building the web we see. Ionization's patchwork, uneven across skies, reflects this stochastic dawn, mapped by telescopes like the James Webb peering to Z-10, revealing compact galaxies with vigorous starbursts, a youthful vigor now mellowed in our mature epoch. Futureward, stellar generations dwindle as gas exhausts. Black holes dominate remnants until proton decay, if it occurs, erodes baryons over 10 to 34 years, leaving a dilute photon gas, dark energy smoothing to uniformity in heat death's hush. A profound stillness where even black holes evaporate. Infinity's canvas blank, yet pregnant with possibility in cyclic or multiversal renewal. The structure formation era, post-recombination, saw acoustic peaks evolve into potential wells that drew baryons, dark matter halos accreting gas to spin up disks. A gravitational choreography where angular momentum from tidal torques preserves the spiral's grace, observed in simulations that replicate the diversity from ellipticals to bars, a computational mirror of the universe's sculpting hand. Feedback mechanisms, from supernovae quenching small halos to active nuclei expelling gas, regulate growth, preventing overproduction and fostering the observed bimodality in color magnitude diagrams, where red quiescent galaxies outnumber blue star formers at high masses, a self-limiting harmony that echoes ecological balances on Earth, where abundance yields to equilibrium in the cosmic ecosystem. The star formation history peaks at Saturn II, when gas-rich mergers fueled intense bursts, declining to the present quiescent rate as black hole feedback heats halos. A temporal arc mapped by infrared surveys that trace dust-obscured activity, revealing how the universe transitioned from fiery youth to contemplative middle age, much like a life settling into wisdom after vigorous beginnings. Cosmic downsizing, where massive galaxies form stars early while dwarfs lag behind, reflects hierarchical merging, where large halos assemble quickly but feedback suppresses late activity, observed in luminosity functions that show the peak shifting to higher redshifts for brighter objects. A maturational gradient that sculpts the galaxy population like aging trees in a forest, their crowns reaching full span before the understory catches up in shaded persistence. The metal enrichment timeline, from population 3's pristine output to the iron peaks in today's disks, tracks the diffusion of elements through outflows and infall, a gradual alloying that prepares the medium for complexity, much like seasoning a canvas over strokes, each layer building depth until the portrait of habitability emerges in soft, enduring tones. The cosmic star formation rate density, integrated over volume, shows a decline post-peak driven by gas exhaustion and heating, with contributions from dusty sub-millimeter galaxies at high Z dominating the budget, their obscured bursts unveiling a hidden vigor in the early web, like embers glowing beneath ash, sustaining the universe's luminous heritage through veiled persistence. Galaxy-quenching mechanisms, such as environmental ram pressure in clusters stripping gas, or morphological changes stabilizing disks against inflows, create the red sequence's dominance, observed in environmental dependence of specific star formation rates, a selective calming where dense regions foster retirement, much like a bustling city, quieting its outskirts first, allowing the core's rhythm to echo in tranquil suburbs. The assembly of massive ellipticals through dry mergers of gas-poor progenitors builds the red and dead population, their velocity dispersions tracing merger histories in fundamental plane deviations. A consolidation phase where fragments unite into monolithic forms, like puzzle pieces fitting into a serene mosaic, preserving the web's architectural poise through successive unions. The epoch of peak quasar activity, around Zatu 3, saw supermassive black holes grow rapidly by accreting gas from merging hosts, their luminosity density rivaling star formations, a symbiotic blaze where black hole feedback balanced growth, observed in bolometric corrections from X-ray to IR. A luminous interlude where the universe's central engines lit the path to maturity, much like a central fire warming a gathering before their embers settle into lasting warmth. The transition to the degenerate era, billions of years hence, where white dwarfs and brown dwarfs dominate after red giants fade, will see a cooling cosmos lit by faint remnants. Their slow contraction a final whisper of stellar life, a quiet retirement where the universe reflects on its luminous past in subdued tones, inviting eternal contemplation in the deepening hush. The Zeta-0 galaxy census, from SDSS and Gamma surveys, catalogues the present diversity, with mergers rare but ongoing in gas-poor pairs, a settled landscape where evolution slows to subtle tweaks, observed in pair fractions declining with mass, like a mature forest where new growth nestles among ancients, maintaining vitality in quiet persistence. The rionization sources, beyond stars to mini-quasars or POP3 binaries, contribute ionizing photons unevenly, modeled in 21 centimeters tomography from Hera, a patchy dawn where bubbles grow and overlap, much like soapsuds merging in a bath, gradually clearing the fog to reveal the structured light beyond. The Dark Ages signal, a smooth 21 centimeter absorption trough from neutral gas cooling the CMB, probes pre-stellar epochs, observed in Edge's experiments anomaly at 78 MHz, a cold shadow where cosmic rays or exotic physics deepen the dip, like a brief chill before the fire's kindling, hinting at early warmth sources in the universe's hushed prelude. The Lyman alpha forest, absorption lines from intergalactic hydrogen in quasar spectra, traces density fluctuations at high Z, their clustering quantifying bias, a gaseous fingerprint where filaments etch the sightline, much like rain streaks on a window revealing wind patterns, mapping the web's early weave in spectral subtlety. The Zunyaev-Zeldovich effect, inverse Compton scattering of CMB by hot cluster gas, imprints decrement in microwave, scaled by cluster mass, observed in Planck SZ catalogues, a thermal echo where electrons boost photon energies, like a warm hand imprinting on cool clay, revealing massive nodes in the web's quiet thermal map. The 21 centi global signals evolution, from absorption to emission as stars heat the IGM, forecasts detectability with future arrays. A red-shifted whisper from cosmic dawn, much like a faint radio tuning to distant stations, capturing the universe's first murmurs in hydrogen's resonant voice. The fossil record in globular clusters, with multiple stellar populations showing helium variations from AGB pollution, reveals self-enrichment in early halos, observed in Na-O anticorrelations, a primordial mixing where the cluster's own giants seeded the next generation, like a family recipe passed inward, sustaining the sphere's ancient glow through internal legacy. The intergalactic medium's multiphase structure, warm-hot at 10 tet 7 K, traced by over-eye absorption, cools via conduction fronts from clusters, a thermal layering observed in fused spectra, where shocks heat and radiation cools in balance, much like atmospheric strata holding varied climes, fostering the web's gaseous diversity in quiet stratification. The epoch of helium reionization at Zenith 3 from quasars' hard UV alters the IgM's opacity, seen in tissue Li-alpha proximity effects, a second clearing where helium doubly ionizes, like a deeper cleanse following the first light, refining the medium's transparency for the universe's ongoing visibility. The cosmic infrared background, unresolved flux from early galaxies and dust, carries hidden light from reionization, detected by CYBER as excess at 1-2 microns. A veiled glow where obscured stars contribute, much like fireflies behind leaves, illuminating the dawn's obscured vigor in subtle persistence. As our journey through galaxies, planets, stars, black holes, nebulae, time, matter, and the infinite softens into quiet, feel the weight of the cosmos lifting from your thoughts. You've traveled far tonight, from the breaking of a distant comet to the heart of creation itself, weaving through the breaths and silences that bind it all, from quantum whispers to galactic symphonies, from elemental forges to philosophical depths, from evolutionary arcs to the quiet vastness of futures untold, from interstellar flows to the resonant philosophies that tie it together, from nucleosynthetic crafts to the grand timelines of change, from structural sheets to the braided quantum edges, from philosophical veils to the enriched cosmic palette, from ringed wanderers to hypergiant farewells, from axionic mists to binary hums, from light echoes to filament spines, from indigenous kinships to eusocial resonances, from neutrino nudges to quenching calms, from cosmic downsizing to the hushed void's grace, from multi-phase media to topological whispers, from anionic braids to domain veils, from hidden signals to peak quasar glows, from degenerate embers to the eternal hush, each layer a gentle invitation to deeper peace, a tapestry of wonders inviting rest where the universe's serene expanse cradles your own dreams in eternal harmony. A boundless lullaby echoing softly into the night, enveloping you in the gentle tide of stars and silence, from cryovolcanic stirrings to shell galaxy pages, from carbon planet depths to microquasar heartbeats, from young envelope unveilings to wall-like whispers, a final whisper of unity in the infinite's embrace, where every filament and fluctuation, every isotope and ideal, merges into the soft rhythm of repose, from polar ring orthogonals to protoplanetary gaps, from tidal evolution locks to metabolic windows, from grain alignments to Planck epoch foams, from supertask compressions to aesthetic prunings, from VP process winds to 21 centimeter dawns, from fossil enrichments to SZ thermal hands, from Lyman forest etchings to helium clearings, from dipole sways to cosmic variance patches, a profound settling where the cosmos's vast narrative folds into your breath's quiet cadence, drifting ever deeper into tranquil infinity. Thank you for joining me on Dreams of Gravity. May you drift into a peaceful sleep carried by the stars. Good night and sweet dreams among the infinite wonders.